Have you ever felt like something about human history just doesn't add up? Like there's a missing puzzle piece, something lurking in the shadows of time, something science hasn't fully uncovered yet? What if I told you that there are gaps in our evolution so bizarre, so unsettling, that even experts struggle to explain them? That buried beneath layers of history are skulls that don't fit any known species, lost civilizations that shouldn't exist, and genetic codes that whisper of something unnatural. And the strangest part? Some of these mysteries are hidden in plain sight, right in our own DNA. Tonight, as you settle in, you're about to go on a journey through the eerie, the unexplained, and the mind-bending secrets of human evolution. You'll hear stories of ghost ancestors who left their mark on our genes but vanished without a trace. You'll learn about tiny hobbit humans who lived side by side with us, until they didn't. You'll question why our brains suddenly tripled in size, why ancient cultures sculpted skulls into strange, elongated shapes, and why some bloodlines carry something so rare and unexplainable that it defies logic. And by the time we reach the final mystery, you may start to wonder, are we really who we think we are? This isn't just a history lesson. This is a deep dive into the cracks of reality, the mysteries of our existence that could change how you see yourself forever. So, get comfortable, dim the lights, and let's begin. There are moments in history where everything seems to make sense, where evidence lines up perfectly, like a trail leading from the past to the present. But then, there are gaps, holes so deep that they threaten to unravel everything we think we know about our origins. One of the most unsettling mysteries in human evolution is not just what we have discovered, but what we haven't. There's a silence in the fossil record, a missing chapter in the story of how we became who we are. Scientists have searched, theorized, and debated, yet the truth remains elusive. Somewhere in the depths of time, something happened. Something that science still cannot explain. If we evolved naturally from our primate ancestors, the evidence should be clear. Fossils should tell the story in a neat, logical order. Yet, between the early primates and modern Homo sapiens, there is an unbridgeable gap. The transition is blurred, almost as if a key player in our history has been erased, forgotten, or simply never found. Could an undiscovered species hold the answer? Was there once another intelligent being that played a role in shaping what we are today? Or is there something far stranger at play, something beyond conventional science? The further we dig, the more questions arise. Paleontologists have unearthed remains of various hominin species, Neanderthals, Denisovans, Homo erectus, and even mysterious groups that have only left traces in our DNA. Each of these species tells part of the story, yet none of them fully bridge the gap. There is no seamless link that explains how we made the leap from primitive ancestors to modern, self-aware beings capable of art, language, and deep thought. Some researchers suggest that the gap is merely a product of time, fossils lost to erosion, buried too deep to find. Others propose that we're simply missing a single crucial discovery that would rewrite everything we thought we knew. But there's another theory, one that shakes the very foundation of human history. What if the gap exists because something changed us in a way that no other species experienced? The leap from primitive hominins to Homo sapiens was not gradual. It was abrupt, almost unnatural in its speed. Other species evolve over millions of years in small, steady steps. But in our case, something accelerated the process. One moment, we were simple tool users, no different from other primates. The next, we were developing language, building societies, and creating art that reflected not just survival, but complex thought. What could have triggered such a leap? Some anthropologists believe that an undiscovered hominin species may have contributed to our genetic makeup, leaving behind traces of themselves within us. Others argue that environmental pressures forced rapid adaptations, leading to unexpected cognitive shifts, but neither of these explanations fully account for why we alone, among all other species, broke through the limits of biology. One of the most controversial ideas is that we were influenced by something outside of evolution itself. This doesn't necessarily mean intervention by an external force. It could mean a genetic mutation so extreme that it defies known evolutionary patterns. Some geneticists have pointed to the sudden expansion of our brain as a clue, noting that no other species has undergone such a radical transformation in such a short period of time. But even if we assume natural selection played a role, we are still left with one unsettling truth. Somewhere in our past, something went missing. A link in our ancestry that should be there, yet isn't. The problem isn't just one of fossils. The deeper issue lies in how human consciousness emerged. Intelligence alone does not explain self-awareness, creativity, or the ability to imagine possibilities beyond survival. These are not traits we see developing at a steady pace over millions of years. Instead, they seem to have exploded into existence, bypassing the usual slow crawl of evolution. Many scientists believe that Homo erectus, a species that lived over 1 million years ago, was an important precursor to modern humans. They had fire, tools, and basic communication. But they existed for over 1 million years with minimal change. Then suddenly, something happened. A new species, Homo sapiens, emerged, seemingly out of nowhere, and within a few thousand years, we had already surpassed every other species in intelligence, dominance, and adaptability. This abrupt transformation has puzzled scientists for decades. Why did we change so drastically while our ancestors remained relatively unchanged for millions of years? Some argue that an environmental catastrophe forced us to evolve faster, while others believe that interbreeding with an unknown species gave us an advantage. But there's a bigger question. If another species contributed to our evolution, why haven't we found them? Why do they exist only as a shadow in our DNA? A whisper of something that was once here, but has now vanished. The search for the missing link is not just about fossils, it's about understanding what makes us human. What separated us from the animals? What turned us into beings capable of thought, creativity, and self-reflection? And why does the evidence feel incomplete, as though a crucial part of our story has been erased? There have been discoveries that hint at answers, but they raise more questions than they resolve. In Africa, a skull was found that had traits of both modern humans and an unknown species. It didn't fit neatly into any category. It was something in between. Other fossils have shown signs of human-like intelligence at times when Homo sapiens shouldn't have existed. And then there are the genetic anomalies. Some human populations carry genes that don't match anything we've identified in the known hominin species. These genes seem ancient, older than even Neanderthal or Denisovan DNA, yet they have no known origin. Could they be remnants of the missing link, a species that existed in the shadows of history, leaving behind only fragments of their existence? Even our earliest cave paintings hint at something unsettling. The first signs of human art appear suddenly, as though an invisible switch was flipped in our ancestors' minds. One moment, early humans were surviving just like any other species. The next, they were painting on cave walls, carving statues, and expressing abstract ideas. Some researchers believe that a major cognitive shift took place around 50,000 years ago, one that allowed humans to think in ways that no other species ever had. But what caused it? And why did it happen so fast? One of the most controversial theories is that early humans may have encountered something that changed them forever. Some propose that interactions with an unknown species, one that was intelligent but not human, could have influenced our development. Others suggest that natural psychedelics found in plants might have triggered expanded consciousness, pushing the human mind beyond its biological limits. Whatever the answer, one thing is clear. There is a chapter in human history that is missing, and until we find it, we will never fully understand where we came from, or why we became something unlike anything else on Earth. The missing link remains one of the greatest unsolved mysteries of human evolution. It is the void in our past, the question that lingers, the evidence that refuses to be found. And yet, in the depths of our own DNA, in the silent spaces of the fossil record, and in the echoes of ancient history, the truth is waiting, waiting to be uncovered, waiting to challenge everything we thought we knew. The past is not silent. It speaks in whispers, coded within bones, etched into our DNA, and buried beneath layers of time. But not all voices from history are heard. Some are mere shadows, slipping through the cracks of human knowledge, leaving behind only fragments of their existence. Among these spectral figures of evolution, one mystery stands out, not because of what we know, but because of how little evidence there is. A species that should have vanished without a trace, yet somehow its presence lingers in the very fabric of certain human populations. The Denisovans are unlike anything else in human history. They were not discovered through grand excavation sites, nor did they leave behind vast settlements or tools that defined their legacy. Their existence was first uncovered through something as small as a single finger bone, deep within a Siberian cave. That tiny fragment, barely enough to tell a story, revealed something no one expected, a lost branch of humanity that once walked the earth. The discovery should have been insignificant. A single bone, on its own, means little in the vast history of evolution. But when scientists analyzed its DNA, they found something shocking. It did not belong to Homo sapiens. It was not Neanderthal. It was something else entirely, a human-like species that had remained hidden for tens of thousands of years, its genetic fingerprint still present in people today. Traces of Denisovan DNA are found in certain populations, primarily in Melanesians, indigenous Australians, and some East Asian groups. Yet, curiously, they are almost absent in others. Why did these ancient people vanish from history while leaving an invisible imprint in select bloodlines? What did they look like? How did they live? And most disturbingly, why is there no clear record of them outside of their genetic traces? Unlike Neanderthals, who left behind countless fossils and artifacts, Denisovans seem to have simply disappeared. What remains of them is so little that their entire species is reconstructed from a few bone fragments and teeth. There are no Denisovan villages to study, no cultural relics to analyze, just pieces of their bodies and traces in our DNA. But their genetic contribution is not meaningless. Some of the genes inherited from Denisovans seem to have given modern humans advantages in high-altitude survival. Tibetan populations, for example, carry a Denisovan gene that allows them to thrive in low-oxygen environments, an adaptation essential for life in the Himalayas. How could a species that vanished still shape the very physiology of people living today? This genetic influence raises unsettling questions. If Denisovans were significant enough to leave an imprint on our biology, why do we know so little about them? Fossil records suggest they existed for tens of thousands of years, possibly even longer, but their physical remains are so scarce that it seems almost intentional, as though history itself has erased them. Some theories suggest they lived in isolated regions, away from the harsh competition that wiped out other hominin species. Others propose that they blended seamlessly with Homo sapiens, interbreeding until their distinct identity faded. But there is another possibility, one that few discuss. What if the Denisovans were far more advanced than we assume? What if their way of life made them less reliant on leaving behind the usual traces of civilization? While Neanderthals carved tools and left evidence of their survival struggles, what if Denisovans adapted differently, thriving in environments where little evidence would remain? A striking possibility emerges when examining ancient myths and folklore. Many cultures speak of lost civilizations, beings that were almost human, yet different. Myths of giant races, hidden mountain dwellers, and mysterious beings who taught early humans knowledge they should not have possessed. Could these stories be distant echoes of real encounters? Could Denisovans have been the inspiration behind these ancient legends? A major challenge in studying Denisovans is that their fossils are not concentrated in a single region. While their DNA has been identified in modern humans, their remains have been found in only a handful of places: Siberia, Tibet, and Southeast Asia. This distribution suggests they were widespread, yet their physical traces are almost non-existent. The discovery of a Denisovan jawbone in Tibet added another layer to the mystery. It suggested that they were not just confined to a single area, but were well adapted to extreme environments. This means they must have been resourceful, highly capable, and possibly even more resilient than Neanderthals. If they were so adaptable, why did they disappear? The answer might lie in the most unsettling theory of all, that Denisovans did not simply die out, but were selectively absorbed into Homo sapiens populations. This wouldn't mean simple interbreeding, but rather a gradual merging, where one group's identity is entirely overtaken by another. It would explain why their genes persist, but their culture and physical traits have seemingly vanished. There are also unexplored possibilities that genetics alone cannot fully explain. Could Denisovans have possessed unique traits that made them distinct from both Homo sapiens and Neanderthals in ways we do not yet understand? Did they have different levels of intelligence, different forms of communication, or even biological advantages that we have yet to uncover? If Denisovans were more advanced in some way, it would not be the first time history has erased a competing species. Early Homo sapiens had a tendency to dominate and absorb other human groups, sometimes peacefully, sometimes violently. If Denisovans posed a challenge, whether intellectually, socially, or biologically, would early humans have seen them as allies or as threats? One of the most striking aspects of the Denisovan mystery is the possibility that we have only scratched the surface. If a single finger bone was enough to rewrite human history, how much more is still waiting to be found? What if their greatest secrets remain buried in places no one has looked? The search for more Denisovan remains continues, but their presence in modern genetics suggests that their story is far from over. If their DNA still affects human traits today, then in a way, they never truly vanished. They are still here, silent, unseen, but forever woven into the fabric of who we are. And yet, their absence from historical records leaves a question that refuses to go away. Did they disappear naturally, lost in the slow march of evolution? Or was their end something else entirely, something we may never fully understand? For now, the Denisovans remain a ghostly presence in human history, not quite forgotten, yet never fully seen. Their bones tell a story that is still incomplete, and their DNA whispers of a past that refuses to be erased. And if they are just one piece of the puzzle, one fragment of the unknown, then what other lost branches of humanity are still waiting to be uncovered? What else have we missed? What other silent figures from our past are hidden, just beyond the edges of history, waiting to be found? The past has a way of keeping secrets. Even when traces of the past surface, they do so in ways that defy explanation, silent, unassuming, yet carrying implications that could rewrite everything. The Denisovans were one such secret, a forgotten branch of humanity that only revealed itself through whispers in our DNA. But they were not the only ones. Thousands of years ago, deep within the dense forests and caves of a remote Indonesian island, another hidden species thrived. They were unlike any other known human relative, so small in stature, yet so strikingly human-like, that their discovery sent shock waves through the scientific world. Homo floresiensis, often referred to as hobbits due to their diminutive size, should not have existed. Their remains were found on the island of Flores, suggesting that a completely separate human species lived in isolation, undisturbed, long after Neanderthals and Denisovans had vanished. But the mystery does not end there. These small beings were not just a variation of modern humans suffering from growth disorders. Their skeletal structure was distinct. Their brains were small, yet they appeared to have crafted tools, used fire, and possibly even hunted cooperatively. Everything about them contradicts what scientists expected from such a small-brained species. Evolution is supposed to follow a pattern, a steady march toward increasing complexity. Yet here was a species that had survived, possibly into the time of early Homo sapiens, without adhering to those rules. Their existence poses an unsettling question. How many other lost human species once walked the earth, leaving behind only faint traces that may never be found? The discovery of Homo floresiensis in 2003 was initially dismissed by some as an anomaly, an aberration in the fossil record. Some scientists argued that these tiny beings were merely deformed modern humans. Others believed they were evidence of an isolated population of Homo erectus that had become smaller due to evolutionary pressures. But as more research emerged, it became clear that this was something entirely different. They were their own distinct species, separate from Homo sapiens, Neanderthals, and Denisovans. And yet, despite their small size and tiny brains, they had somehow mastered survival. They lived on Flores for tens of thousands of years, possibly even longer, before disappearing. But the question that lingers is, why did they vanish? The presence of Homo sapiens on the island might provide an answer. Evidence suggests that early modern humans arrived in Southeast Asia around the same time that Homo floresiensis disappeared. If history tells us anything, it's that whenever two human species coexisted, one always ended up outcompeted or absorbed. But there is something unusual about this case. Unlike Neanderthals or Denisovans, Homo floresiensis was not competing with Homo sapiens on equal footing. They were much smaller, possibly weaker, yet they had survived in their environment for thousands of years. Their extinction was sudden, raising the possibility that they did not merely fade away, they were wiped out. If that is true, why have no records of early human encounters with these beings been found? Why do they exist only as skeletons, with no signs of cultural interaction? Local folklore in Flores tells of small, human-like creatures known as the ebugogo, described as tiny beings that could speak in murmurs, steal food, and even occasionally abduct human children. Some islanders claim that their ancestors had encounters with these beings and that they lived in the forests well into recent history. Could it be that these stories are not just myths, but distant recollections of encounters between Homo sapiens and the last surviving members of Homo floresiensis? There is another question that makes this mystery even more unsettling. If they were isolated for so long, how did they develop tool-making skills, advanced hunting techniques, and possibly even fire use? With a brain no larger than that of a chimpanzee, how did they show cognitive abilities comparable to much larger-brained hominins? Some anthropologists argue that brain size is not the only measure of intelligence. The structure and efficiency of the brain may have played a role. If so, Homo floresiensis challenges the very foundation of what it means to be an intelligent species. Could it be that human intelligence, as we define it, is not unique to Homo sapiens? Another strange aspect of their story is how they arrived on Flores in the first place. The island has been surrounded by deep ocean waters for over 1 million years. There were no natural land bridges connecting it to nearby regions. If Homo floresiensis descended from an earlier hominin species, how did they cross the sea? Some scientists believe that their ancestors, possibly Homo erectus, accidentally arrived on the island by floating on debris or being swept away by storms. But others suggest a far more controversial idea. What if they arrived by deliberate means? What if their ancestors had developed some form of primitive water navigation, something that predates even the earliest known boat-building efforts of Homo sapiens? If that is the case, then the implications are staggering. It would mean that an ancient, small-brained hominin species had developed survival skills that we previously believed were unique to modern humans. Homo floresiensis also presents another problem for evolutionary models. Their physical traits resemble species that should have gone extinct over 1 million years ago, yet they survived until relatively recently, possibly coexisting with early humans. This suggests that the evolutionary tree is far more complex than we assumed. Instead of a neat progression from primitive to advanced species, there may have been multiple human-like groups coexisting, each adapting in unique ways. Some researchers believe that Homo floresiensis represents a case of reverse evolution, where instead of growing larger and more complex, they became smaller and retained ancient traits to survive in their environment. If true, this means evolution does not always favor expansion or complexity. Sometimes it takes unexpected turns. Adding to the mystery is the fact that no one knows exactly when they disappeared. The most recent fossils date back at least 50,000 years, but some researchers believe they may have survived much longer. The dense forests of Flores are largely unexplored. Could it be that remnants of this species survived into historical times, hiding in remote regions? Even more unsettling is the idea that other unknown human species might still exist in uncharted territories. If Homo floresiensis could remain undiscovered for so long, what else might still be out there? Could there be small, isolated populations of unknown hominins in dense rainforests, deep caves, or remote islands waiting to be found? The implications of their existence reach beyond anthropology. If intelligence developed separately in multiple species, it challenges the idea that Homo sapiens are unique in their cognitive abilities. It also raises the question of what other forms of intelligence might have existed in the past, forms that did not rely on large brains but on different adaptations. Homo floresiensis is a reminder that history is incomplete. Their discovery rewrote what was believed to be a straightforward story of human evolution. It suggests that the past was filled with far more diversity than we once thought. The idea that only one human species survived into the present is no longer certain. The skeletons found in Flores are not just relics of an extinct species. They are proof that the world once held many kinds of human-like beings, each carving out their own survival. Some were larger, some were stronger, and some, like Homo floresiensis, were small yet remarkably capable. But if they could exist in secrecy for so long, what else remains hidden in the shadows of history? What other human species once thrived in places we have yet to explore, and how many more chapters of our past remain unwritten? There are gaps in history that can be explained by missing fossils, lost artifacts, or forgotten civilizations. But then there are gaps that exist not in ancient ruins, but within us, coded deep inside the very fabric of our DNA. Some stories are written in bones, others in genes, and what they reveal is even more unsettling than what is buried beneath the earth. For centuries, science has worked to map the human genome, to trace the origins of modern populations and unravel the complex story of how we came to be. We know that Homo sapiens interbred with Neanderthals, leaving behind traces of their DNA in non-African populations. We know that Denisovans contributed genetic material to certain groups, influencing traits like high-altitude survival, but as researchers sifted through the data, they found something that did not fit. There are fragments of genetic code in modern humans that do not match any known ancestor. They do not belong to Homo sapiens. They do not align perfectly with Neanderthals or Denisovans. They appear to come from something else, something that has never been identified in the fossil record, a hidden lineage that left its mark in our DNA but vanished without a trace. Some populations, particularly in Africa and parts of Asia, carry genetic markers that suggest interbreeding with an entirely unknown species. These markers do not resemble those of any recognized hominin group. They suggest an ancient encounter long before recorded history, where early humans encountered and mixed with beings that have since disappeared from the physical world but still exist within us. The existence of these unknown genes raises troubling questions. If another hominin species interbred with Homo sapiens, why have we not found their fossils? If they were widespread enough to leave genetic imprints in multiple regions, how could they have vanished so completely? And perhaps the most unsettling question of all, how different were they from us? The idea that an unidentified hominin species contributed to our genetic makeup challenges everything we thought we knew about early human migration. Scientists have long assumed that Homo sapiens emerged in Africa, spread across the globe, and occasionally interbred with Neanderthals and Denisovans, but the presence of unidentified genes suggests that we were not alone, that somewhere along the way we encountered others. The theory of ghost lineages in human evolution has gained traction in recent years. This refers to species that left genetic traces without leaving physical remains. It suggests that some hominin groups may have existed in small, isolated populations, their fossils lost to time, their bones never preserved. If true, this would mean that human history is far more complex than a simple tree of descent. Instead, it may have been a tangled web of interbreeding, where different species met, mixed, and vanished. Some researchers believe that these unknown genes could come from an archaic species that diverged from the common ancestor of humans, Neanderthals and Denisovans, millions of years ago. Others suspect that an isolated group of hominins, possibly deep in the forests of Africa or remote regions of Asia, survived long enough to contribute to the gene pool before fading into extinction. There are even more controversial theories. Some anthropologists suggest that the unknown genes could point to the survival of a species more advanced than previously thought, one that may have had its own culture, language, or even technology. If they were sophisticated enough, they might have left no clear trace of their existence, either because they avoided conflict with Homo sapiens or because they were wiped out before they could leave significant evidence behind. Another mystery is why these genetic fragments have been found in some populations but not others. While Neanderthal DNA is present in nearly all non-African populations, the unknown genes appear to be concentrated in specific groups, particularly in West African and some Southeast Asian lineages. This suggests that the encounters between early humans and this mysterious species were not global, but rather limited to certain regions. If this unknown hominin group played a role in shaping human genetics, then what other traits might we have inherited from them? Some scientists speculate that certain cognitive abilities, immune system adaptations, or even behavioral tendencies may be linked to these ghost ancestors. But without fossil evidence, their full impact on modern humans remains a puzzle. The existence of unexplained DNA fragments also raises ethical and philosophical questions. If there was another intelligent species that contributed to human evolution, does this challenge our understanding of what it means to be human? Were we truly alone in our rise, or were there others? Others who walked alongside us, shared knowledge, and then disappeared. Some researchers point to oral traditions and ancient myths as potential clues. Many cultures around the world have legends of mysterious beings, figures who were human-like but different, possessing knowledge or abilities beyond those of early humans. Could these myths be distant memories of encounters with lost hominin groups, stories that survived long after their physical traces were erased? The idea that our ancestors may have lived alongside another unknown species is not entirely implausible. Recent discoveries suggest that early Homo sapiens, Neanderthals, and Denisovans were not separate entities that evolved in isolation. Instead, they frequently interacted, traded, and even interbred. If one unknown group was also present in this mix, it would not be surprising if they, too, contributed to the complex tapestry of human ancestry. The challenge is that DNA evidence alone cannot tell the full story. Without fossils, without tools, without artifacts, the identity of this unknown group remains speculative, but the genetic clues are real, and they refuse to be ignored. One of the most baffling aspects of this mystery is that some of these genetic markers appear to be extremely old, possibly dating back hundreds of thousands of years. If a species existed long enough to leave a permanent imprint in our DNA, it means they must have been successful in their own way. They survived, adapted, and thrived, only to vanish in ways that science has yet to uncover. The search for this missing species continues, and with advances in genetic research, scientists may one day find a breakthrough. If new fossils emerge that match the unknown DNA sequences, it could redefine human history. It would mean that we were not the only intelligent beings shaping the world in prehistoric times. For now, the ghost of this lost species lingers in fragments of code buried within us, a genetic echo of something ancient, something unrecorded, something that lived, thrived, and disappeared, but never truly left. If our DNA carries secrets we have yet to decode, then what else lies hidden within us? What other stories are written in our genes, waiting to be uncovered? And if this is just one mystery among many, how much of our history remains unknown, waiting, just beneath the surface, to change everything we think we know? The unknown traces in human DNA tell us one thing for certain: our history is far more complex than what is written in textbooks. An unidentified ancestor left a genetic fingerprint, an echo of a species that existed long enough to shape our biology, but vanished without leaving a single confirmed fossil. If genes can preserve the memory of something unseen, then what else has gone unnoticed? The mysteries buried in human evolution do not stop at missing ancestors. There is an even greater anomaly, one that does not just involve an undiscovered species, but challenges the very mechanics of evolution itself. Human intelligence is often presented as the natural outcome of evolutionary progress, but the reality is far more puzzling. At some point in the distant past, something happened that cannot be explained by gradual evolution alone. The human brain, once no different from those of other primates, underwent an explosion in size and complexity. It tripled in volume within a remarkably short period of time, an event that defies conventional biological patterns. No other species has experienced a cognitive leap of this magnitude. Other animals have evolved intelligence, problem-solving abilities, and social structures, but none have undergone such a sudden and dramatic expansion of brain power. Neanderthals and Denisovans, despite being close relatives, did not undergo the same rapid changes. Why did this transformation happen to us, and why did it happen so fast? The speed of this development presents an evolutionary paradox. Natural selection typically works through slow, incremental changes over long periods. Small adaptations accumulate across generations, shaping species gradually. Yet, the human brain appears to have expanded at an unprecedented rate, skipping expected steps in evolutionary development. Some scientists suggest that environmental pressures played a role. A dramatic shift in climate may have forced early hominins to become more adaptable, selecting for individuals with superior problem-solving abilities. Others propose that the shift to a more diverse diet, particularly the consumption of nutrient-rich meat and seafood, provided the necessary energy for brain growth. Yet, these explanations do not fully account for the scale of the change. If diet and environment alone were responsible, why did no other species experience a comparable leap? Why did intelligence, at the level seen in Homo sapiens, emerge so abruptly rather than gradually developing over millions of years? One of the most debated theories is that a genetic mutation, or a series of mutations, occurred in our ancestors, altering the trajectory of our development. These mutations may have rewired neural pathways, increasing cognitive efficiency in ways that had never been seen before. If true, this would suggest that human intelligence was not the result of slow evolutionary progress, but of an unpredictable, near-instantaneous event. The expansion of the human brain did not merely increase intelligence, it brought with it self-awareness, abstract thought, art, language, and the ability to question existence itself. This is not just a matter of having a larger brain. It is about the emergence of consciousness in a way that had never been seen before. Some researchers argue that the development of social complexity was a driving force. As early humans began to live in more organized groups, those with greater cognitive abilities had an advantage. The ability to predict behavior, communicate effectively, and solve problems would have contributed to survival. Over time, this may have created an evolutionary feedback loop, where intelligence became the most valuable trait, accelerating its own expansion. Yet this explanation still does not resolve the underlying mystery. Intelligence is advantageous, but it comes at a cost. Large brains require enormous amounts of energy, making them an inefficient adaptation unless they provide an overwhelming survival benefit. Why, then, was this transformation so extreme? One of the most unusual aspects of human brain expansion is its apparent randomness. Fossil evidence suggests that for millions of years, early hominins showed only minor changes in brain size. Then, suddenly, in a window of roughly 2 million years, a blink in evolutionary time, the brain more than tripled in volume. This pattern is not seen elsewhere in the animal kingdom. One controversial theory is that external factors played a role, factors that go beyond traditional evolutionary mechanisms. Some researchers have speculated that human intelligence may have been influenced by encounters with unknown species, whether through interbreeding or other forms of interaction. Others suggest that exposure to hallucinogenic plants may have triggered cognitive shifts, altering brain function in ways that accelerated problem-solving abilities. Another line of thought focuses on the role of culture in driving evolution. Unlike genetic changes, cultural knowledge can be transmitted instantly across generations. If early hominins developed even a rudimentary form of teaching or language, they could have rapidly passed down survival techniques, leading to accelerated progress. This would mean that human intelligence was not purely biological, but also a product of shared learning. The shift toward toolmaking also coincided with brain expansion. Some experts believe that once early humans began crafting and using tools, it set off a chain reaction, forcing individuals to think ahead, plan, and refine techniques. This, in turn, may have selected for greater cognitive abilities, reinforcing the trend toward rapid development. However, these explanations do not fully account for the sheer magnitude of the change. Evolutionary pressures can shape species, but they rarely produce such dramatic transformations in such a short span of time. The sheer complexity of human thought, creativity, and self-awareness raises the question of whether traditional evolutionary models can adequately explain what happened. Another mystery is why brain expansion slowed down. If intelligence is such a valuable trait, why did it not continue to grow at the same rate? There is no clear reason why the brain stopped expanding once it reached its current size. Some theories suggest that further growth would have posed structural problems. Human skulls could only accommodate so much brain tissue without becoming impractical for childbirth. Others believe that, at a certain point, intelligence may have reached a threshold where further expansion was no longer necessary. What makes this even more perplexing is that while brain size is linked to intelligence, it is not the only factor. Some species, such as dolphins and elephants, have large brains relative to their body size, yet they did not undergo the same leap in cognition as humans. This suggests that it was not just brain volume that changed, but the internal organization of neural connections, something that is not easily preserved in fossils. The genetic basis of this transformation remains poorly understood. Studies have identified certain genes that seem to be involved in brain development, but their effects are still being explored. Some mutations, such as those affecting the FOXP2 gene, have been linked to language abilities, while others appear to regulate neural growth. Yet, no single mutation has been found that fully explains why humans alone underwent this extraordinary leap. If the brain's sudden expansion was the result of a unique combination of genetic changes, environmental pressures, and social structures, then it represents one of the most extraordinary events in natural history. But if there is a missing factor, something that has yet to be discovered, then human intelligence remains an unsolved puzzle. Some researchers believe that additional evidence may still be buried, waiting to be found. There may be fossilized remains of early hominins with intermediate brain sizes, revealing the missing steps in this transformation. Or there may be undiscovered genetic sequences that hold the key to understanding how cognition developed. What is certain is that human intelligence is an anomaly. The rapid expansion of the brain defies expectations, standing as a singular event in evolution. Other species adapted to their environments through physical changes, longer limbs, sharper teeth, stronger muscles. But humans took a different path. Intelligence became the defining trait, allowing Homo sapiens to shape the world rather than be shaped by it. If the human brain is the product of forces we do not yet fully understand, then its expansion was not just a biological event. It was a moment in history that changed the course of the planet, creating a species capable of questioning its own existence. And if it happened once, in such an inexplicable way, then the most pressing question remains: could it happen again? Could the next evolutionary leap already be unfolding, unnoticed, waiting to reveal itself in the future? The expansion of the human brain was not just an evolutionary anomaly, it was the foundation upon which civilization was built. Intelligence alone did not make us unique. What set us apart was the ability to organize, innovate, and leave behind structures that could outlast generations. But what if those structures are far older than we think? What if human civilization did not begin in the way we have been taught, but instead stretches back much further, to a time when the world looked completely different? The narrative of human history has long followed a familiar pattern. Small hunter-gatherer groups slowly evolved into settled agricultural societies, which in turn gave rise to the first cities. Mesopotamia, Egypt, and the Indus Valley civilizations are widely regarded as the earliest known examples of advanced societies. Yet, discoveries continue to surface that challenge this timeline, revealing structures and artifacts that suggest organized civilizations existed long before what history records. Göbekli Tepe, a site in modern-day Turkey, is one of the most baffling archaeological discoveries of the past century. It was built over 11,000 years ago, predating the Egyptian pyramids and Stonehenge by thousands of years. Its massive stone pillars, intricately carved with animal figures, suggest a level of sophistication that should not have existed at the time. According to traditional archaeology, humans were still primitive at this stage, lacking the organizational skills and technology to construct such monuments. Yet, the evidence stands firm. Someone, or some group, built it. The implications of Göbekli Tepe are unsettling. If human civilization was capable of creating such grand structures during the Neolithic period, what else has been lost to time? Could there have been entire societies that flourished and collapsed long before recorded history? If so, where is the evidence? One of the biggest challenges in identifying lost civilizations is the relentless passage of time. Most ancient structures that once stood have been swallowed by the earth, eroded by nature, or submerged beneath rising seas. The end of the last ice age saw dramatic shifts in global climate and sea levels. If civilizations existed before this period, much of their physical evidence could have been erased. This raises a question. If the only evidence of an advanced society is now deep under the ocean or buried beneath layers of sediment, how much of human history remains undiscovered? There are sites across the world that hint at answers. Off the coast of India, beneath the waters of the Gulf of Kambat, sonar scans have revealed massive structures that resemble city grids. These submerged ruins suggest that an ancient settlement once thrived there before being swallowed by the sea. In South America, unexplained megalithic structures like those at Sacsayhuaman in Peru defy conventional explanations. The precision with which the stones were cut and fitted together without mortar suggests a lost engineering technique beyond what was thought possible for early civilizations. Some researchers propose that these findings point to a forgotten chapter in human evolution, one where societies rose to great heights before being wiped out by catastrophic events. Mainstream archaeology often dismisses these theories, arguing that evidence of such civilizations is too scarce. But the lack of evidence does not prove non-existence, only that what remains has not yet been found. The possibility of lost civilizations also raises deeper questions about human development. If societies capable of building monumental structures existed thousands of years before Mesopotamia, why did they vanish? Did they collapse due to environmental disaster, war, or disease? If humanity had reached a high level of advancement before recorded history, what prevented that progress from continuing uninterrupted? The idea of forgotten civilizations is not new. Ancient myths and legends from different cultures speak of lost golden ages, times when great societies thrived before suffering destruction. The legend of Atlantis, as described by Plato, tells of an advanced civilization that was wiped out in a cataclysmic event. Many dismiss this as mere mythology, but could such stories hold echoes of real historical events? There are gaps in the historical record that suggest humanity may have had to start over more than once. The Dark Ages of Europe, following the collapse of the Roman Empire, show how knowledge and technological advancement can be lost within a few generations. If such a collapse happened in prehistory, wiping out an advanced civilization, could it be that later human societies had to begin again, relearning what was once known? The potential existence of lost civilizations also forces us to rethink the timeline of technological development. We often assume that modern technology is the pinnacle of human achievement, yet many ancient structures contain elements that remain unexplained. The pyramids of Egypt, the step pyramids of Mesoamerica, and the megalithic sites in Malta all show signs of advanced planning and construction techniques that do not match the supposed technological capabilities of their time. Some theories suggest that an earlier civilization, with knowledge of engineering and astronomy, influenced later cultures. Certain alignments of ancient sites with celestial bodies hint at a deep understanding of astronomy long before it was believed to have been developed. If a forgotten society had mapped the stars and built structures aligned with cosmic events, then much of what we credit to later civilizations may have actually been inherited knowledge. Another piece of the puzzle lies in unexplained artifacts, objects that do not fit within established historical timelines. The Antikythera mechanism, discovered in an ancient shipwreck, is a sophisticated device that functioned as an astronomical calculator. It dates back to over 2,000 years ago, yet its complexity rivals that of 18th century clockwork. If such an advanced tool existed in the ancient world, what else might have been lost? The reluctance to acknowledge the possibility of lost civilizations often comes from the limitations of conventional archaeology. Science relies on physical evidence, and without clear artifacts or written records, many theories remain speculative. However, new discoveries continue to challenge assumptions, forcing scholars to reconsider what was once thought impossible. The human story may not be as linear as we believe. Instead of a straight line from primitive ancestors to modern civilization, history may be a cycle, one where societies rise, collapse, and are forgotten, only to be rediscovered thousands of years later. If advanced civilizations once existed, their absence from history books is not proof of their non-existence, but rather a testament to how easily time erases even the greatest achievements. If Göbekli Tepe is proof that early humans were capable of far more than previously believed, then what other sites remain buried beneath deserts, jungles, or oceans? How much of our own history has been lost, waiting to be uncovered? And if civilizations have risen and fallen before, what does that mean for the future of humanity? There is still so much we do not know. The past is not as distant as it seems. It lingers, hidden beneath the surface, waiting for us to look deeper. And when we finally do, it may not just change our understanding of history, it may change everything. The remnants of lost civilizations challenge the story of human history, revealing that advanced societies may have existed long before recorded time, but civilization is only part of the mystery. The people who built them, the ones who shaped the world before their names were forgotten, may not have been exactly like us. The more we uncover, the more it becomes clear that human evolution is not as straightforward as once believed. There are anomalies, pieces of evidence that do not fit neatly into the accepted lineage. Some of the most unsettling clues come not from artifacts or ruins, but from the very bones of ancient beings. Throughout history, archaeologists and paleontologists have unearthed skulls that defy categorization. Some have features that do not match any known hominin species. Others seem to possess traits from multiple groups, suggesting hybrid origins. A few appear to be so far removed from anything currently recognized that they raise the question of whether another branch of humanity once existed, one that vanished before it could be fully understood. The problem with these discoveries is that they disrupt the carefully constructed framework of human evolution. Each time a new skull is found, it should help clarify the timeline, adding another link in the chain of human ancestry. Instead, certain skulls create more confusion, as they do not resemble anything previously documented. Some possess elongated craniums without evidence of artificial skull shaping. Others have brain capacities that seem too large or too small for their time period. And a few have jaw structures that suggest they were not purely Homo sapiens, nor entirely Neanderthal or Denisovan. One of the most debated cases involves skulls discovered in China, sometimes referred to as the Red Deer Cave people. These remains, found in caves in southern China, exhibit a mix of primitive and modern traits, yet they are relatively young in the fossil record. Their unusual features, including thick skull bones, large molars, and a different facial structure than other early humans in the region, make it unclear whether they represent an unknown species, an isolated population of early humans, or a group that interbred with an unidentified hominin. Another controversial find is the Dragon Man skull, discovered in northeast China. This fossil, which dates back over 140,000 years, possesses characteristics that set it apart from Neanderthals and Homo sapiens. Its massive size and unique facial structure suggest that it may belong to a separate branch of hominins, possibly one that coexisted with our ancestors but left little other evidence of its existence. If confirmed as a distinct species, it would mean that multiple human-like groups occupied different parts of the world at the same time, further complicating the story of human migration and interaction. The mysteries are not limited to Asia. In Africa, where modern humans are believed to have originated, researchers have discovered skulls that seem out of place in the timeline. Some of these fossils have features that resemble those of earlier hominins, even though they are far younger than expected. This suggests that ancient human relatives may have survived much longer than previously believed, coexisting with Homo sapiens instead of being entirely replaced by them. One of the most unsettling aspects of these findings is what they imply about the diversity of ancient hominins. If multiple species or subspecies of humans lived at the same time, why do our history books present such a simplified version of our origins? If Homo sapiens interacted with other human-like beings, why is there so little direct evidence of these encounters? Some researchers propose that these unknown groups were absorbed through interbreeding, their traits blending into modern human populations and leaving behind only faint genetic traces. Others suggest that they were driven to extinction by early Homo sapiens, either through competition for resources or more direct conflict. But there is another possibility, one that is rarely discussed. What if these groups never had a chance to leave behind a legacy because they were actively erased? The concept of unknown human relatives coexisting with our ancestors raises uncomfortable questions. If they were intelligent, if they had their own cultures and ways of life, why did they disappear while Homo sapiens survived? Did early humans view them as competitors, as threats, or as something else entirely? Could there have been deliberate efforts to eliminate them, ensuring that only one version of humanity remained? There is also the question of why some of these skulls appear to possess features that are inconsistent with known evolutionary trends. In some cases, the combination of traits seems almost unnatural, as if two entirely different species had somehow merged into one. This raises the possibility that human evolution was not a straightforward progression, but a complex web of interactions, with multiple groups influencing each other in ways that we do not yet fully understand. Some discoveries hint at even deeper mysteries. In certain cases, skulls have been found that appear unusually elongated, with cranial capacities that exceed what should have been possible for their time period. While some elongated skulls can be explained by artificial cranial deformation, a practice found in many ancient cultures, others do not show the telltale signs of being modified. If these skulls were naturally formed, it would mean that there were once populations of humans with head shapes dramatically different from those of modern Homo sapiens. The Paracas skulls of Peru are one of the most well-known examples of this phenomenon. These skulls, discovered in burial sites, have an extreme elongation that differs from those created by skull binding. Some researchers argue that their unique shape is the result of genetic factors rather than artificial modification. If this is true, then it suggests that an unknown population with distinct anatomical features once lived in the region, separate from other known groups of early humans. The anomalies do not end with skull shape. Some skulls have dental structures that do not fit within the normal patterns of human evolution. Teeth with unusual root formations, jawbones with unexpected shapes, and mandibles that lack clear evolutionary connections all point to the possibility that there were once populations of humans who followed a different developmental path. The challenge with these discoveries is that they often do not receive the same level of attention as fossils that fit within established scientific models. When a skull aligns with expectations, it is studied, classified, and added to the record. But when a skull raises new questions, when it does not fit neatly into the human family tree, it is often dismissed as an anomaly rather than explored as a potential key to understanding a hidden aspect of our past. This reluctance to confront the unknown is not limited to ancient history. Even today, there are reports from remote regions of the world of human-like beings that do not match any recognized population. Indigenous groups have long told stories of small, humanoid creatures living in forests and mountains, beings that are neither fully human nor entirely animal. While such accounts are often categorized as folklore, they share striking similarities with the idea that lost hominin species may have survived longer than previously believed. If ancient skulls do not fit into the timeline, then the timeline itself must be reconsidered. If fossils exist that suggest unknown human relatives once walked the earth, then our understanding of human history is incomplete. And if entire populations of early hominins disappeared without explanation, then the question is not just who they were, but why they were erased. The search for answers continues, but the deeper one looks, the more unsettling the questions become. If human evolution is not as simple as we once thought, then what else remains hidden? If lost civilizations reshaped the course of history, then who were the people who built them? And if ancient skulls do not match any known species, then how many more chapters of our past remain undiscovered? If ancient skulls do not match any known human species, then what does that say about our understanding of history? There are limits to what bones alone can reveal, but when patterns emerge across multiple civilizations, patterns that defy conventional explanations, questions must be asked. One of the most perplexing phenomena found in ancient cultures around the world is the deliberate practice of skull elongation. At first, this might seem like an odd ritual, nothing more than a cultural aesthetic choice, but the more one studies it, the stranger it becomes. From the Paracas culture in Peru to the Mangbetu people of Central Africa, from the ancient Maya to the royal families of ancient Egypt, elongated skulls appear throughout human history, separated by vast distances and thousands of years. Why did so many societies engage in this practice? And more importantly, who were they trying to resemble? Many skulls found in these cultures exhibit extreme elongation. Some have been artificially shaped through cranial binding, a method where infants' heads were tightly wrapped with cloth or wooden boards to encourage their skulls to grow into an elongated form. But there are skulls, such as the famous Paracas skulls of Peru, that present a far deeper mystery. These do not appear to have been shaped artificially, as their cranial volume is significantly larger than that of a normal human skull. If these individuals were born with naturally elongated skulls, then they were not entirely Homo sapiens. One of the most puzzling aspects of elongated skulls is their widespread appearance across cultures that had no known contact with each other. The ancient Egyptian pharaoh Akhenaten and his family were depicted with elongated heads, a feature that stands out in comparison to the more typical representations of royalty. In Mesoamerica, skull elongation was associated with nobility, suggesting that those with elongated heads were seen as superior in some way. Among the Mangbetu people of Africa, elongation was considered a sign of intelligence and beauty. Why was this feature so highly valued in so many different parts of the world? The traditional explanation is that skull elongation was a status symbol, much like jewelry or elaborate clothing. But this does not explain why so many societies independently developed the same practice, nor does it explain why they associated it with higher intelligence. spirituality, or even divine status. Some researchers propose that these cultures were trying to imitate a lost elite, an ancient group of beings who naturally possessed elongated skulls and were seen as superior. If true, then who were these beings? The presence of naturally elongated skulls among the Paracas people adds weight to this idea. Unlike artificially modified skulls, which retain the same cranial volume as a normal human skull, Paracas skulls have an entirely different bone structure. Their cranial capacity is up to 25% larger than that of modern humans. This suggests that they were not the result of head binding, but rather the genetic inheritance of a population distinct from Homo sapiens. Could this be evidence of an unknown branch of humanity? If so, where did they come from, and why do they no longer exist? DNA testing on Paracas skulls has revealed another anomaly. Some genetic markers found in these skulls do not match known Native American or typical human DNA patterns. They show affinities with populations from Europe and the Middle East, despite their location in South America. This has led to speculation that the Paracas people were not originally from the Americas, but arrived there through unknown means. If they were descendants of an ancient group that had once lived elsewhere, it would suggest a migration pattern not currently recognized by mainstream archaeology. The Egyptian connection adds another layer of complexity. Akhenaten, one of the most enigmatic pharaohs in history, was frequently depicted with an elongated skull. His wife, Nefertiti, and his children were also shown with similar head shapes. Some scholars argue that this was merely an artistic convention, but others point out that Egyptian royal families often practiced genetic isolation, meaning that any unusual traits could have been hereditary. If Akhenaten and his lineage truly had elongated skulls, then this trait may have been preserved from an older, forgotten bloodline. The idea that ancient rulers may have inherited physical traits from a lost lineage could explain why certain families were seen as divine. Many cultures describe their rulers as having descended from the gods, and elongated skulls were often associated with supernatural wisdom or celestial origins. Were these just myths, or were they remnants of an older truth distorted through time? The presence of elongated skulls in Mesoamerican civilizations is equally intriguing. The Maya and the Olmec, among others, practiced skull modification extensively, often binding the heads of infants to create a sloped forehead and elongated cranium. In some cases, these individuals were given special roles in society, treated as priests, leaders, or even living representations of deities. If skull elongation was merely aesthetic, why was it so consistently linked with higher social status and spiritual importance? Another unanswered question is whether elongated skulls affected cognitive function. Did they have any impact on intelligence, perception, or neurological processing? There is no definitive evidence that people with elongated skulls were more intelligent, but the fact that so many societies associated them with wisdom suggests that they were perceived as different in ways beyond just physical appearance. Some researchers speculate that an elongated cranium may have affected brain organization, possibly influencing abstract thinking or problem-solving abilities. The possibility of a lost hominin species with naturally elongated skulls raises further questions about human evolution. If such a group once existed, why have their remains been so difficult to find? It is possible that they were a relatively small population, their numbers dwindling until they were absorbed into the broader human gene pool or driven to extinction. If they had distinct cultural practices or lived in isolated regions, their presence might have been erased over time, leaving only scattered traces in genetic markers and ancient traditions. Some researchers believe that the answer to this mystery lies in ancient oral traditions. Many indigenous groups have stories of encounters with tall ones, shining ones, or people of great wisdom who arrived from distant lands and passed down knowledge before disappearing. While these legends are often dismissed as myths, they share remarkable similarities across cultures. Could they be distorted memories of interactions with an ancient people who looked different from the rest of humanity? The presence of elongated skulls in different parts of the world also raises questions about ancient migration. How did this practice spread so widely if these civilizations were not connected? Did knowledge of skull elongation travel through trade routes, or was there an older civilization that influenced multiple cultures in ways we do not yet understand? One of the most controversial theories is that elongated skulls were not just a human trait, but evidence of something even more unusual. Some researchers suggest that myths of gods or celestial beings with elongated heads might be based on real encounters with an advanced group that was separate from Homo sapiens. While this idea is often dismissed by mainstream science, it continues to attract interest due to the sheer number of cultures that independently depicted elongated-headed beings in their art, statues, and religious iconography. Ultimately, the mystery of elongated skulls remains unsolved. The most accepted explanation is that it was a widespread cultural practice, but this does not account for the naturally elongated skulls found in certain regions, the genetic anomalies in some remains, or the repeated association between elongated skulls and divine or elite status. If an ancient population once existed with these traits, their disappearance raises yet another question: were they simply lost to time, or was their presence deliberately erased? The more we uncover about the past, the more we realize how much is still missing. The physical evidence suggests that the human story is far from complete. If civilizations rose and fell before recorded history, if unknown hominin species left traces in our DNA, then the elongated skulls found across the world might be another fragment of a hidden past waiting to be understood. If their true origins were ever revealed, they could rewrite everything we thought we knew about who we are and where we come from. The elongated skulls scattered across ancient civilizations hint at a deeper, more complex history, one that suggests humanity has shared this planet with other beings, other variations of what it means to be human. If skeletal anomalies raise questions about unknown lineages, then genetic anomalies pose an even greater mystery. DNA is the blueprint of life, the one thing that should tie all living beings together in a clear, traceable lineage. And yet, hidden within human genetics is something that defies conventional understanding, a trait found in no other known primates. The Rh-negative blood type is one of the greatest anomalies in human biology. Blood classification follows patterns in the animal kingdom, with primates, our closest evolutionary relatives, sharing similar blood groupings. Yet, Rh-negative blood does not fit. It appears suddenly in human populations, behaves differently from Rh-positive blood, and carries medical implications that have puzzled scientists for decades. Where did it come from? Why does it exist in only a minority of the human population? And why does it appear to act as if it rejects Rh-positive blood, as though it recognizes something foreign? One of the most perplexing aspects of Rh-negative blood is the way it affects pregnancy. When an Rh-negative mother carries an Rh-positive fetus, her immune system may attack the developing child as though it were an invader. This condition, known as hemolytic disease of the newborn, HDN, does not occur in any other mammalian species. If evolution follows a natural course, why would a human mother's body react so aggressively to her own offspring? This is not typical of a trait passed down through natural selection. It is an anomaly, an inconsistency in the biological order. The prevalence of Rh-negative blood is not evenly distributed across the world. It appears most frequently in certain populations, particularly among the Basque people of Spain and France, as well as in certain Jewish and Celtic groups. These populations have unusually high concentrations of Rh-negative individuals, far above global averages. Why would this specific blood type be concentrated in isolated genetic clusters rather than evenly spread across humanity? Was it introduced by an unknown ancestral group that remained relatively separate from the rest of the human population? Mainstream science attributes Rh-negative blood to a genetic mutation that occurred at some point in the distant past. However, this does not fully explain its presence. Mutations typically follow patterns of inheritance, and while blood type mutations can occur, they do not usually create fundamental incompatibilities within a species. A mutation that results in an immune system rejection of one's own kind is not an advantageous evolutionary trait. If it was a random occurrence, why did it persist? Some researchers propose that Rh-negative blood may be a remnant of an unknown branch of hominins, one that interbred with Homo sapiens but left little other trace of its existence. If this is true, then the individuals who carried this blood type may have belonged to a separate lineage, one with unique physiological differences. But if they were human, why do no known primates or earlier hominin species carry the trait? There are even more controversial theories that suggest Rh-negative blood may indicate a non-terrestrial origin. Some researchers have pointed out that myths and religious texts throughout history frequently describe beings from the sky who interacted with early humans. The concept of celestial visitors, whether described as gods, spirits, or advanced entities, appears in multiple ancient cultures, many of which also display an unusual reverence for bloodlines and genetic purity. Could the presence of Rh-negative blood be evidence of an external influence on human genetics? Another peculiar detail is that Rh-negative individuals are more likely to have certain physical traits. Studies have shown that people with Rh-negative blood often have a slightly lower than average body temperature, an increased sensitivity to sunlight, and in some cases, heightened intuition or cognitive processing speeds. While these traits do not necessarily prove anything extraordinary, their correlation raises further questions about whether Rh-negative individuals possess subtle physiological differences beyond their blood composition. There is also the question of why blood donation restrictions exist for Rh-negative individuals. Those with Rh-negative blood are often advised to only receive transfusions from other Rh-negative donors, as their immune systems may react negatively to Rh-positive blood. This suggests a fundamental incompatibility between the two types, almost as if they belong to different biological classifications rather than simply being variations of the same species. The mystery deepens when examining ancient history. Blood rituals and genetic lineage purity were central to many early civilizations. Royal families often practiced interbreeding to maintain divine bloodlines, a tradition seen in ancient Egypt, Mesopotamia, and pre-Columbian America. In some cases, rulers were even described as descendants of the gods, with a different kind of blood. While these could be symbolic references, it is curious that many of these ruling bloodlines can be traced to populations with high concentrations of Rh-negative individuals. One of the most compelling aspects of the Rh-negative mystery is its complete absence in other primates. If humans evolved directly from a shared ancestor with apes, why does this blood type appear exclusively in Homo sapiens? Even Neanderthals and Denisovans, our closest known relatives, do not seem to have carried Rh-negative blood. If this trait did not come from standard evolutionary progression, then what is its true origin? The implications of this anomaly stretch beyond biology. If an unknown factor introduced Rh-negative blood into the human population, then what else might have been altered in our genetic past? Could it be that early human ancestors encountered another intelligent species, one that left behind not only cultural influence but biological traces as well? If so, were these interactions peaceful exchanges of knowledge, or was there a more complex, possibly darker history that has been lost over time? One of the more controversial studies in this area involves correlations between Rh-negative blood and unusual cognitive patterns. Some researchers have suggested that individuals with Rh-negative blood show a higher prevalence of anomalous brainwave activity, particularly in areas associated with intuition and perception. While mainstream science does not support these claims, the idea that certain biological traits might influence cognition and awareness remains a topic of speculation. There are also medical peculiarities linked to Rh-negative blood. Certain autoimmune disorders and neurological conditions appear at slightly higher rates among Rh-negative individuals, though the reasons for this are not fully understood. If Rh-negative blood carries with it unique genetic factors, could these also play a role in human physiology beyond just blood compatibility? If Rh-negative blood is simply a mutation, then why does it come with so many unexplained side effects? If it was introduced through interbreeding with an unknown hominin species, then why do we have no clear fossil evidence of that species? And if it was not a product of Earth's evolutionary processes at all, then what does that mean for human history? Despite advances in genetic research, the mystery of Rh-negative blood remains unresolved. Mainstream explanations struggle to account for all of its anomalies, and alternative theories, while intriguing, lack the necessary physical evidence to be confirmed. What is clear is that Rh-negative individuals are biologically distinct in ways that go beyond a simple classification of blood type. If history has taught us anything, it is that the past is rarely what it seems. The more we uncover, the more we realize how little we truly know. Blood should be a link between all humans, a shared biological foundation. And yet, buried within our veins is a contradiction, a clue that suggests the story of human evolution may not be as straightforward as we were led to believe. If this one genetic trait has remained an enigma for so long, then how many other mysteries lie hidden within us, waiting to be understood? And if the truth about our origins is far more complex than we ever imagined, then what else about human history has been forgotten, buried beneath time, or deliberately concealed? If something as fundamental as human blood carries an unexplainable anomaly, then the story of our past is still incomplete. Rh-negative blood raises the possibility of genetic influences that are not accounted for in the standard model of human evolution. But there is another mystery, one that involves not just an unusual trait, but an entire species. For tens of thousands of years, another human-like group walked the earth. They hunted, gathered, built shelters, used fire, made tools, and even engaged in artistic expression. They had larger brains than modern humans, strong bodies adapted for survival, and lived in harsh environments where resilience was a necessity. Yet, despite their intelligence and adaptability, they are no longer here. The disappearance of Neanderthals is one of the most haunting, unsolved questions in human history. For over 200,000 years, they thrived across Europe and parts of Asia, surviving through ice ages and environmental upheavals. Then, about 40,000 years ago, they vanished forever. The question is not just how they disappeared, but whether Homo sapiens had something to do with it. Many explanations have been proposed. Climate change may have played a role, reducing the Neanderthals' access to food sources and forcing them into competition with other species. Disease, brought by migrating Homo sapiens, could have devastated their population. Some believe they were absorbed through interbreeding, their distinct traits diluted into the modern human gene pool. But there is another possibility, one that suggests their disappearance was not an accident of nature, but something far more deliberate. Neanderthals were not mindless brutes. They buried their dead, suggesting they had rituals and possibly even a belief system. They crafted tools that were just as sophisticated as those used by early Homo sapiens. They even lived in small social groups, forming bonds that resemble modern human communities. Despite all of this, they were driven to extinction while Homo sapiens flourished. One of the most unsettling theories is that early modern humans may have played a direct role in their downfall. If Homo sapiens encountered Neanderthals, there were only a few possible outcomes. They could have coexisted peacefully, remained separate, interbred, or fought. The archaeological record suggests that while some interbreeding did occur, it was not widespread enough to fully integrate Neanderthals into the human population. This leaves the possibility that they were eliminated, either through direct conflict or competition that left them unable to survive. The overlap in time between Neanderthals and early Homo sapiens is striking. Fossil evidence indicates that the two species lived in the same regions for thousands of years. This was not a brief encounter, but an extended period of cohabitation. If Neanderthals were simply less capable of surviving environmental changes, they would have declined gradually over time. Instead, their disappearance is abrupt, a sharp vanishing from the fossil record. There are signs that suggest Neanderthals and Homo sapiens may have clashed. Some Neanderthal fossils show evidence of trauma, injuries that could have been caused by weapons. Homo sapiens had more advanced hunting strategies and greater numbers, which may have given them an advantage. In a world where resources were scarce, would early humans have seen Neanderthals as competition that needed to be eliminated? One of the biggest advantages Homo sapiens had over Neanderthals was not physical, but social. Early humans developed more complex social structures, forming larger groups and cooperating in ways that may have given them dominance. This ability to organize and strategize could have allowed them to outcompete Neanderthals for food, shelter, and territory. Neanderthals were adapted to colder climates, their bodies built for endurance and strength rather than speed. When Homo sapiens arrived, bringing with them new tools, weapons, and possibly new diseases, Neanderthals may have found themselves at a disadvantage. If conflicts broke out, early humans had the numbers and technology to win. Yet, if Homo sapiens were responsible for the disappearance of Neanderthals, why did they not do the same to other archaic human species, such as the Denisovans? One possibility is that Neanderthals occupied territory that was prime real estate for survival. Their strongholds in Europe and the Middle East would have been valuable land, leading to direct competition with Homo sapiens. Genetic evidence shows that modern humans carry traces of Neanderthal DNA, meaning some level of interbreeding occurred. However, the amount of Neanderthal genetic material in living humans is small, suggesting that their integration into Homo sapiens was limited. This does not support the idea that they were gradually absorbed into the human population. Instead, it suggests that their numbers dwindled rapidly, whether due to environmental pressures or a more direct cause. Some researchers argue that Neanderthals may have been outcompeted rather than directly exterminated. Homo sapiens had a more diverse diet, accessing a wider range of food sources. They developed more advanced hunting techniques, allowing them to track and kill prey more efficiently. They also built shelters that provided better protection against the elements. If Neanderthals struggled to adapt to changing conditions, their decline may have been a slow process of losing ground to the more adaptable Homo sapiens. However, there are indications that Neanderthals were not as limited as once believed. Recent discoveries show that they were capable of abstract thought, creating cave paintings and ornaments that suggest a form of symbolic expression. They may have had language, though it is still debated how complex their communication abilities were. If they were capable of art and culture, then they were more like us than previously thought. This raises another question. If they were so similar to us, why did they disappear? If Neanderthals had survived into modern times, the world would look very different. The idea of multiple human species coexisting today is almost unimaginable, yet for most of prehistory, this was the norm. Homo sapiens were not alone. They shared the planet with Neanderthals, Denisovans, and possibly even other unknown hominin species. If Neanderthals had not gone extinct, they could have developed alongside Homo sapiens, creating a world where multiple intelligent species shaped civilization together. Instead, they vanished, leaving only fragments of their existence behind. The reasons for their extinction remain elusive, but the possibility that early Homo sapiens played a role in their disappearance cannot be ignored. There are those who argue that Neanderthals were simply doomed from the start. Their population was always small, making them vulnerable to extinction even without human interference. Climate changes, disease outbreaks, and genetic bottlenecks may have contributed to their decline. If they were already struggling, then Homo sapiens may have simply been the final factor that pushed them over the edge. Yet, if Neanderthals had been given more time, could they have adapted? Could they have merged with Homo sapiens in a way that preserved their unique traits? The limited interbreeding that did occur suggests that there was no absolute barrier preventing the two species from mixing. If circumstances had been different, would we still see Neanderthals walking among us today, indistinguishable from modern humans, except for small genetic variations? The disappearance of Neanderthals is a reminder of how fragile existence can be. They were intelligent, resourceful, and well adapted to their environment, yet they vanished while Homo sapiens survived. If history had taken a different path, the story of humanity might have included multiple species shaping civilization together rather than one species dominating the entire planet. The question of why Neanderthals went extinct remains open. Whether they were gradually outcompeted, wiped out through conflict, or fell victim to environmental catastrophe, their fate serves as a warning. Survival is never guaranteed, no matter how intelligent or strong a species may be. If Homo sapiens did play a role in their extinction, then it raises uncomfortable questions about our nature. Were early humans driven by a survival instinct so powerful that it led them to eliminate their closest relatives? If so, what does that say about the way humanity approaches competition, conflict, and dominance? What happened to the Neanderthals is not just a story about the past. It is a reflection of the forces that shaped humanity, forces that continue to influence us today. If we could erase an entire species once, what prevents it from happening again? And if Neanderthals were not the only ones who disappeared, then how many other branches of humanity have been lost, their existence reduced to nothing but bones and unanswered questions? If the disappearance of Neanderthals reveals the brutal competition that shaped early human survival, then the genetic changes that distinguish Homo sapiens from all other primates offer an even deeper mystery. The extinction of our closest relatives left us as the last remaining human species on Earth. But in that process, something extraordinary happened to us, something that has no clear precedent in the evolutionary history of primates. While nearly every other mammal adapted by growing fur for warmth, protection, and survival, humans went in the opposite direction. At some point in the distant past, we shed our fur almost entirely. The question is why? This transformation defies the expected pattern of evolution. Fur serves an essential function in regulating body temperature, shielding against environmental hazards, and providing a layer of defense against insects, parasites, and UV radiation. Most primates retained their fur as they evolved, yet Homo sapiens lost it. The implications of this shift go beyond simple adaptation. There must have been a strong evolutionary pressure for such a drastic change. One of the most commonly proposed explanations is that humans became hairless as a response to overheating. As early hominins moved into open environments, such as the African savannas, their bodies needed a more efficient way to regulate temperature. Sweating became a primary cooling mechanism, and dense fur would have interfered with this process. Losing fur may have allowed early humans to remain active in hot conditions for longer periods, outlasting prey through endurance hunting. While this explanation is widely accepted, it does not fully explain why humans became so much more hairless than other mammals that also adapted to hot climates. Other large land animals that live in warm environments, such as lions, antelopes, and elephants, did not evolve to become completely hairless. They retained fur or developed other mechanisms for heat regulation. If hair loss was solely about cooling, then why did no other species take it to the extreme that humans did? Even chimps, our closest relatives, managed to thrive in warm environments while keeping their fur. This suggests that the change in humans was driven by more than just temperature regulation. Another theory points to an aquatic phase in human evolution, suggesting that our ancestors spent a significant amount of time in or near water. Marine mammals, such as dolphins and whales, lost their fur to become more hydrodynamic. Some researchers propose that early hominins may have relied on water-based food sources, developing adaptations that led to hair loss. The problem with this idea is the lack of fossil evidence supporting an extended aquatic phase. However, it does explain why humans have a layer of subcutaneous fat similar to that of marine mammals, which is uncommon among land animals. A more unsettling possibility is that human hairlessness was influenced by factors other than environmental adaptation. Some genetic changes do not occur randomly, but are the result of selective pressures that remain poorly understood. If early humans interbred with an unknown hominin species, one that already exhibited reduced body hair, this could have accelerated the transition. There is also the possibility that hair loss provided an unexpected advantage in social structures or mate selection, leading to its persistence across generations. One of the most puzzling aspects of human hairlessness is the way in which hair remains on certain parts of the body while disappearing elsewhere. While fur vanished from the arms, legs, and torso, humans retained it on the scalp, eyebrows, and, to a lesser degree, the pubic region. This suggests that while overall body hair was no longer necessary, certain areas still served a crucial function. Scalp hair protects against sun exposure, while eyebrows prevent sweat from running into the eyes. But why did humans not develop a uniform coat of short, thin hair rather than losing most of it entirely? Sexual selection may have played a role. Some scientists believe that smooth, hairless skin became associated with health and reproductive fitness, leading to a preference for less body hair over time. This theory, however, does not account for why the process occurred so rapidly in evolutionary terms. Hair patterns do not change drastically in most mammalian species, yet humans underwent a transformation that set them apart from every other primate. Another unusual factor is the way human hair responds to age and hormonal changes. While most mammals have consistent fur coverage throughout life, human hair patterns shift dramatically over time. Infants often have fine hair that changes in texture and thickness as they grow. In adolescence, new hair growth appears in specific areas, while in older adults, hair may thin or turn gray. These shifts suggest that hair plays a more complex role in human biology than simple protection. The loss of fur also exposed humans to new vulnerabilities. Without a thick coat, early Homo sapiens became more susceptible to cold, parasites, and sunburn. To compensate, humans had to develop external solutions, clothing, shelter, and eventually medicinal treatments. No other species relies so heavily on artificial means to regulate body temperature and protect itself from environmental threats. If natural selection had continued along the usual path, Humans should have adapted to extreme climates through physical traits rather than tools. Instead, they became the only species that relies on external modifications for survival. This raises another question. Did humans lose their fur because they found ways to compensate, or did they have to find ways to compensate because they lost their fur? If hair loss occurred first, it would have put early humans at a disadvantage, forcing them to develop new strategies. If it was the result of environmental adaptation, then the transition must have happened quickly enough that humans did not have time to develop alternative physical traits to replace their lost fur. Either way, the change was profound enough to alter the course of human evolution. Another peculiar trait linked to hair loss is the way human skin interacts with sunlight. Unlike most mammals, humans have a high concentration of sweat glands, allowing for better heat dissipation. However, this also means they are more vulnerable to dehydration. The development of dark skin pigmentation in early Homo sapiens helped protect against sun exposure. But this adaptation was not universal. As humans migrated into colder regions, lighter skin evolved to allow for better vitamin D production. If the primary reason for losing fur was temperature regulation, then why did pigmentation need to change separately? Hair also plays a role in nonverbal communication. Facial hair, for example, can influence social interactions, signaling age, status, or even aggression. This is seen in the way beards develop in males, often associated with testosterone levels. Eyebrows and eyelashes, despite their small size, play a key role in human expression, helping convey emotions. If humans had retained a full coat of fur, these subtleties might have been less effective. This suggests that hair loss was not just a biological adaptation, but a factor in the development of human social structures. The sudden loss of fur also coincides with other major evolutionary leaps in human history. It occurred around the same time that Homo sapiens began walking upright, using complex tools, and developing language. This suggests that the change was part of a broader transformation, possibly linked to cognitive or behavioral shifts. Some researchers propose that a genetic mutation affecting hair growth may have also influenced brain development, though this remains speculative. Despite extensive research, the exact reasons for human hair loss remain unknown. While the prevailing theories offer plausible explanations, none fully account for all the factors involved. If it was purely about temperature regulation, then why did other animals in hot climates not follow the same path? If it was due to sexual selection, then why did it occur so uniformly across different human populations? And if it was an inherited trait from an unknown hominin species, then where is the evidence of that species? Whatever the cause, the loss of fur is one of the defining characteristics of Homo sapiens, setting them apart from every other primate. It forced early humans to develop new survival strategies, influenced social behaviors, and shaped the way the species interacted with the environment. If this transformation had not occurred, human history might have unfolded in an entirely different way. If something as fundamental as our own skin remains an evolutionary mystery, then what else about human history has yet to be uncovered? And if this drastic change happened for reasons that remain unclear, then how many other aspects of human evolution are still waiting to be explained? If the loss of human fur remains an unsolved puzzle in evolutionary history, then the timeline of when and where early humans first walked the earth is an even greater enigma. The story of our origins has been built on a framework of carefully dated fossils and artifacts, pieced together over generations. Yet, every so often, something emerges that threatens to tear that framework apart. There are fossils, footprints, and tools that should not exist where they have been found. Objects buried in ancient rock layers, bones in locations where no early humans were supposed to be, and remnants of activity that defy established migration patterns. If human history is a straight line, why do so many discoveries seem to contradict it? The traditional timeline states that Homo sapiens emerged in Africa around 300,000 years ago before spreading to other continents. This migration is believed to have occurred in stages, with evidence pointing to modern humans reaching Europe and Asia about 40,000 to 50,000 years ago, and the Americas much later. However, some fossils suggest that human-like beings may have walked these lands far earlier than expected. These finds are often labeled as anomalies, one-off occurrences that do not fit the broader picture. But the number of these out-of-place fossils is growing. If a single artifact or bone could be dismissed as an error, what happens when multiple discoveries suggest that humans, or something like them, were in places they shouldn't have been, thousands or even millions of years too early? One of the most controversial discoveries comes from Litoli, Tanzania. Fossilized footprints, perfectly preserved in volcanic ash, reveal that a bipedal species walked across the landscape 3.6 million years ago. The problem? According to the conventional timeline, only primitive hominins like Australopithecus existed at that time, yet these footprints resemble those of modern humans. If early hominins were already walking with such a human-like gait millions of years ago, does this mean upright walking evolved much earlier than expected, or that a different species, one remarkably similar to us, existed long before Homo sapiens? The Americas present an even bigger problem. For decades, scientists believed that the first humans arrived in North America no earlier than 13,000 to 15,000 years ago, following an ice-free corridor into the continent. Yet, sites such as the White Sands National Park in New Mexico have produced fossilized human footprints dated to at least 21,000 years ago. Some estimates suggest they could be as old as 23,000 years. This single discovery rewrites the entire narrative of human migration into the Americas, showing that humans were present at a time when the continent was still locked in the grip of the last ice age. This raises critical questions. Who were these early people, and how did they get there so much earlier than previously thought? But the anomalies do not stop at footprints. In Mexico, stone tools were found at the Chiquihuite cave site, dated to around 30,000 years ago, twice the accepted age for human settlement in the region. Similar claims have emerged from Brazil, where artifacts discovered at the Pedra Furada site appear to be over 40,000 years old, challenging the belief that early humans exclusively migrated through North America before spreading south. These findings imply that either humans arrived far earlier than believed, or that another unknown hominin species had already reached the continent. Perhaps even more unsettling are the cases where fossils have been found in rock layers far older than they should be. In 1880, in Castanedolo, Italy, a skeleton was unearthed from Pliocene-era deposits, which are over 3 million years old. If the skeleton is truly that old, it predates Homo sapiens by an enormous margin. Mainstream science has largely dismissed this find as a result of geological disturbance, arguing that the bones were somehow introduced into the older layer. However, other cases of similarly misplaced fossils suggest that the problem may be larger than a single anomaly. Then there are the discoveries that defy not only the timeline of human migration, but the very origins of tool making. In 2017, stone tools were found in India, dated to 385,000 years ago, long before Homo sapiens are believed to have left Africa. This challenges the assumption that modern humans were the first to use advanced tools in the region. Either early Homo sapiens reached India far earlier than expected, or another hominin species, perhaps an unknown group, was responsible. Even more extreme cases push the boundaries of credibility. In 1968, geologists in Mexico discovered what appeared to be worked stone tools in a layer of rock dated to over 250,000 years ago. If confirmed, this would place tool-making hominins in the Americas at a time when Homo sapiens had not even evolved. Similarly, in Hueyatlaco, Mexico, artifacts were unearthed alongside extinct megafauna and dated to over 200,000 years ago. This discovery has been fiercely debated, with some scientists arguing that the dating methods were flawed, while others insist that the evidence is legitimate. The issue is not just that these finds exist, but that they threaten the entire structure of how human evolution is understood. If humans or human-like beings were present in places long before they were supposed to be, then either our timeline is wrong or a separate lineage existed alongside us, leaving only scattered traces behind. The implications are unsettling. If an unknown group of intelligent beings once walked the earth, what became of them? Were they wiped out, absorbed into our species, or did they disappear for reasons we have yet to uncover? Some researchers have suggested that the anomalies could be explained by lost civilizations. The idea that ancient humans may have developed advanced cultures long before recorded history is often dismissed by mainstream science. Yet, if human footprints, tools, and bones continue to appear in places where they should not be, then the possibility of a forgotten past cannot be ignored. Could it be that civilization has risen and fallen multiple times, leaving behind only fragments that defy conventional dating methods? Another possibility is that the process of evolution itself is more complex than we assume. What if human-like beings did not evolve in a single, linear path but in waves, with different populations rising and falling over millions of years? This would mean that Homo sapiens were not the first intelligent species to exist, nor will we necessarily be the last. There could have been others, species that thrived before us, leaving behind only the occasional fossil or artifact that refuses to fit the established model. The implications of these findings stretch beyond science into philosophy and history. If civilizations once flourished before recorded time, then how much knowledge has been lost? If humans arrived in the Americas tens of thousands of years earlier than previously thought, what does that say about the way history has been constructed? And if fossils continue to emerge in locations and time periods where they should not exist, then how much of what we believe about our past needs to be rewritten? Despite these questions, many of these discoveries remain ignored or dismissed, often explained away as misinterpretations or errors. But the number of anomalies is growing. The more we dig, the more we uncover evidence that does not fit. If even a fraction of these out-of-place fossils are genuine, then human history is far older and more complex than we ever imagined. Science is built on evidence, but evidence is only as valuable as our willingness to confront its implications. If footprints, tools, and bones continue to defy expectations, then we must ask ourselves, what else is buried beneath the earth, waiting to challenge everything we think we know? If our timeline is wrong, then what other chapters of human history have been erased, forgotten, or ignored? The deeper we look, the more it becomes clear that the true story of humanity has yet to be fully uncovered. If footprints, tools, and fossils continue to emerge in places where they should not exist, then the very foundations of human evolution are called into question. The deeper we dig, the more we uncover inconsistencies in the timeline of our origins. But there is one transformation in human history that stands as the greatest evolutionary leap of all, one that completely reshaped the destiny of our species. At some point, primates that once moved on all fours stood upright and never looked back. Walking on two legs is one of the defining traits of humanity, yet it remains one of the most mysterious. The transition from quadrupedal movement to bipedalism is not a small adjustment. It is a complete restructuring of skeletal mechanics, muscle function, and balance. Every other primate species continued using their arms for movement, yet our ancestors abandoned this advantage entirely. Why? What force was powerful enough to push early hominins toward upright walking, despite the risks and disadvantages it carried in the short term? Bipedalism is not a universal trend in evolution. Most animals remain quadrupedal, as it offers greater stability, speed, and efficiency in movement. Even primates that occasionally stand upright, such as chimpanzees and gorillas, primarily rely on their arms for support. Yet, for reasons still debated, human ancestors became fully bipedal, altering not just how they moved, but how they interacted with the world. This shift required profound changes to the spine, hips, and legs. It also forced a reorganization of the nervous system to manage balance in a way that no other primate has needed. One of the most widely accepted theories suggests that bipedalism was an adaptation to changing environments. As forests in Africa began to shrink due to climate fluctuations, early hominins may have been forced into open grasslands. Walking upright would have allowed them to see over tall grass, spot predators more easily, and travel longer distances in search of food. But if survival was the only goal, why didn't other primates follow the same path? Why didn't gorillas or chimpanzees, facing similar pressures, develop full bipedalism? Another theory proposes that standing upright freed the hands for other uses, allowing early humans to carry food, tools, and infants more effectively. However, this explanation does not fully account for the risks involved. Bipedal walking is far less stable than quadrupedal movement, making individuals more vulnerable to injury. A single broken leg could be fatal in a prehistoric environment where survival depended on mobility. If natural selection favors traits that increase survival, why would evolution favor an adaptation that initially made movement more dangerous? Energy efficiency has also been suggested as a reason for the shift. Some studies indicate that walking on two legs may require less energy than moving on all fours over long distances. This would have given early humans an advantage in endurance-based hunting and foraging. But while endurance may have been a long-term benefit, early hominins still had to survive the transition period, where they were likely slower and more exposed to predators than their quadrupedal relatives. One of the strangest aspects of bipedalism is how quickly it appears to have developed. Evolution is typically a slow process, occurring over millions of years through gradual changes. Yet, the fossil record shows that early hominins began standing upright much faster than expected. Australopithecus afarensis, the species best known from the famous Lucy skeleton, was walking upright over 3 million years ago. But just a million years earlier, ancestors like Ardipithecus still relied heavily on climbing. This means that in evolutionary terms, bipedalism was not a slow adaptation. It was an abrupt transformation. Rapid evolutionary changes are rare and often indicate that an external force was involved. Some scientists speculate that an unknown environmental event or catastrophe may have triggered the shift. A sudden reduction in tree cover could have made climbing less viable, forcing primates to adapt quickly or perish. Others propose that changes in available food sources may have played a role. If early hominins were forced to travel longer distances for sustenance, walking upright could have been an advantage. But none of these theories fully explain why the change happened so quickly and why it was exclusive to the human lineage. There is also the question of why early bipedal hominins retained so many traits associated with tree-dwelling primates. Fossils suggest that even after standing upright, many early hominins still had curved fingers, flexible ankles, and limb proportions suited for climbing. This means that bipedalism did not immediately replace previous adaptations. It coexisted with them for a time. Why would an evolutionary transition leave behind partial features rather than completely shifting to a new body plan? Some researchers propose that bipedalism may have developed not for movement on land, but for wading through water. According to this theory, early hominins may have lived in flood-prone environments where walking upright through shallow waters provided an advantage. This would explain why bipedalism developed quickly. If early humans spent significant time in water, they would have needed to balance upright frequently. However, this idea remains speculative, as fossil evidence for an aquatic phase in human evolution is limited. The social implications of bipedalism are equally important. Walking upright changed the way early humans interacted with one another. It altered body language, posture, and the ability to carry objects. It may have played a role in the development of communication, as standing upright freed the hands for gestures. Some scientists even believe that bipedalism contributed to brain development by encouraging more complex problem-solving related to movement and balance. Another strange aspect of human bipedalism is the level of physical strain it places on the body. Unlike most evolutionary adaptations, which improve survival, walking upright comes with numerous downsides. The human spine is prone to injury because it supports weight vertically rather than horizontally. Knee and hip joints are heavily stressed, leading to arthritis and other mobility issues. Childbirth is also far more difficult in humans than in other primates due to the changes in pelvis shape required for bipedalism. If bipedalism was purely an advantageous adaptation, why did it develop in a way that introduced so many physical drawbacks? One possibility is that standing upright was not initially meant to be a permanent state. Some researchers suggest that early hominins may have been facultative bipeds, meaning they walked on two legs only when necessary, but still used their arms for support in certain situations. Over time, natural selection may have reinforced upright walking as a dominant trait. However, this still does not explain why bipedalism became the exclusive mode of movement for humans while other primates retained more flexibility. There is also the question of why bipedalism was not reversed once its disadvantages became apparent. Evolution is a process of trial and error. Traits that do not offer long-term benefits are typically discarded. Yet, once bipedalism developed, it remained the defining characteristic of human movement. If early humans experienced physical strain, vulnerability to predators, and increased risk of injury, why did evolution not shift back toward quadrupedalism? Some alternative theories suggest that bipedalism may have been influenced by an external factor, possibly even one beyond traditional evolutionary pressures. Throughout history, myths and legends describe beings that descend from the sky, bringing knowledge and influencing human development. While speculative, some researchers have pointed out that bipedalism is an unusual trait in the animal kingdom, and its rapid development raises questions about whether an unknown force played a role in shaping human evolution. Despite the various theories, the origins of bipedalism remain one of the great unsolved mysteries of human history. Unlike other evolutionary traits that develop gradually and logically, the shift to upright walking happened quickly, came with significant drawbacks, and was exclusive to the human lineage. Whether it was driven by environmental change, social necessity, or an unknown external force, it remains the foundational change that set humanity on a path unlike any other species on Earth. If something as fundamental as how we move remains a mystery, then what else about human evolution is still waiting to be uncovered? And if the transformation to bipedalism happened faster than expected, what other changes might have occurred in ways that science has yet to fully understand? If the shift to bipedalism was the foundation for humanity's physical evolution, then the emergence of consciousness was the moment when the mind broke free from the limits of mere survival. No other evolutionary change reshaped the destiny of a species as profoundly as the sudden ability to think beyond the immediate present. At some unknown point in prehistory, humans did something that no other creature had ever done. They looked at the world and asked, why? The leap from instinct to self-awareness is one of the most perplexing mysteries of evolution. Every living being is programmed to survive, but only humans took that impulse and transformed it into something more. The earliest hominins had no need for philosophy, art, or abstract thought, yet somewhere along the way, something changed. Instead of merely existing, humans became creators, dreamers, and seekers of meaning. Other animals communicate, problem solve, and even show emotional bonds. Elephants mourn their dead, dolphins demonstrate complex social structures, and primates use tools. But none of them create poetry. None of them paint the walls of caves with images that tell stories. None of them wonder about the stars or try to find purpose in suffering. If evolution operates purely on the basis of survival, why did the human brain develop the ability to contemplate its own existence? One of the most unsettling aspects of this transformation is how abruptly it occurred. The fossil record shows that for millions of years, early hominins remained relatively unchanged in their cognitive abilities. Then, around 70,000 years ago, something extraordinary happened. This period, often referred to as the cognitive revolution, marks the moment when Homo sapiens began demonstrating behaviors that no other species had ever exhibited. Archaeological evidence reveals that around this time, humans started engaging in symbolic thinking. Jewelry made from shells, burial rituals that suggest belief in an afterlife, and carvings that depict abstract concepts all appear in the fossil record. These are not the behaviors of a creature merely trying to survive. They are signs of a species that has become aware of something beyond itself. The development of language may have played a key role in this transformation. The ability to convey abstract ideas allowed humans to pass down knowledge, form complex social structures, and cooperate in ways no other animal could. But language alone does not explain the emergence of self-awareness. Many animals communicate, yet none have developed the deep introspection that defines humanity. Some scientists believe that this shift was triggered by a genetic mutation, one that rewired the brain in a way that allowed for higher consciousness. If a single genetic change was responsible for the emergence of self-awareness, it would be one of the most significant mutations in the history of life on Earth. This has led some researchers to propose the existence of what is sometimes called the soul gene, a theoretical genetic marker that may have unlocked humanity's capacity for abstract thought, creativity, and morality. The idea of a consciousness-altering genetic mutation raises even more questions. If the brain evolved to be efficient, why would it suddenly develop the ability to dwell on existential dilemmas, fear death, or experience profound emotions unrelated to survival? Anxiety, grief, and philosophical reflection do not necessarily help a species find food or avoid predators. If evolution is about passing on genes, why did humans develop the ability to question the very meaning of life itself? There is also the question of whether this transformation was truly random. Genetic mutations typically occur over long periods, with minor changes accumulating over thousands or millions of years. But the leap from primitive cognition to fully developed consciousness happened so quickly that it seems almost unnatural. Some scientists have even speculated that this rapid change could indicate an external influence, whether environmental, biological, or something even more unexplainable. The role of psychedelics in the evolution of consciousness has also been debated. Some researchers propose that early humans may have encountered psychoactive plants that temporarily altered their perception of reality. These experiences may have sparked new ways of thinking, pushing the brain to develop in directions it otherwise would not have. While this theory remains speculative, it highlights the possibility that consciousness did not emerge solely through genetic evolution, but may have been influenced by external stimuli that altered brain chemistry in profound ways. One of the most controversial ideas surrounding the emergence of human consciousness is the possibility that it was not a product of random mutation at all, but something else entirely. Myths, religious texts, and ancient traditions from around the world describe moments in which humanity was awakened by an external force. Some cultures speak of gods gifting knowledge, while others describe a sudden enlightenment that set humans apart from the animals. While these stories are often dismissed as mythology, their consistency across civilizations raises the question of whether they are metaphorical recollections of a real event, one that forever changed human cognition. There is also the question of why consciousness, once it emerged, did not fade away. Many traits in evolution appear briefly before disappearing if they do not provide a survival advantage. Yet, the ability to reflect on existence, engage in art, and create complex belief systems became an inseparable part of what it means to be human. Could it be that consciousness itself is an adaptation, one that allowed humans to form societies, pass down knowledge, and shape the world around them? Or is it something entirely different, an anomaly in nature, a deviation from the expected course of evolution? Some scientists argue that the ability to perceive time differently may be at the core of human consciousness. Unlike other animals, humans can imagine the future, reflect on the past, and make decisions based on long-term consequences. This ability allows for planning, goal setting, and the construction of civilizations. But it also introduces suffering. The awareness of mortality, the burden of regret, and the fear of the unknown are byproducts of a brain that is capable of thinking beyond the present moment. If consciousness was an evolutionary accident, then it was one with profound consequences, giving humans the ability to create, but also to despair. Another strange aspect of human consciousness is its link to morality. Unlike other species, humans have an innate sense of right and wrong, even in the absence of formal laws. Studies have shown that even young children display an understanding of fairness, justice, and empathy. Where does this sense of morality come from? Is it a product of evolution, meant to strengthen social bonds and cooperation? Or is it evidence of something deeper, an intrinsic awareness that goes beyond biological survival? Throughout history, many philosophers and scientists have struggled to define what consciousness truly is. Some argue that it is merely a byproduct of neural activity, an illusion created by the brain. Others believe that it is something more, a force that exists independently of biology, perhaps even beyond the limits of physical reality. If consciousness is just a function of the brain, then why has it remained one of the greatest mysteries of science? If it is something more, then what are the implications for human existence? The emergence of self-awareness also raises unsettling questions about the nature of reality itself. If consciousness allows humans to perceive and interpret the world in a unique way, then how much of what we experience is objective truth and how much is a construct of the mind? Some theories suggest that human perception is limited by the brain's biological constraints, meaning that what we consider reality is only a fraction of what actually exists. If this is true, then human consciousness may not be the ultimate stage of evolution, but merely a step towards something even greater, something we have yet to fully comprehend. Despite all the theories, the question remains: what caused the human mind to awaken? Was it a gradual process, shaped by countless small changes over millions of years? Or was it an abrupt shift, a sudden emergence of self-awareness that set humanity on a path no other species has followed? If the answer lies in our genetics, then what triggered that change? And if consciousness is something more than just biology, then what does that mean for the future of human evolution? If bipedalism freed humans to move differently, then consciousness freed them to think differently. But while walking upright reshaped the body, the emergence of self-awareness reshaped existence itself. Whatever caused this shift, it was the moment when humans became something more than just another animal. It was the moment when they began searching for meaning, whether in the stars, in stories, or within themselves. If evolution truly gave rise to the soul, then the question remains, is consciousness a gift or a burden? And is it the final stage of human development or merely the beginning of something even greater? If the emergence of human consciousness was the moment when our species broke free from mere survival and stepped into the realm of introspection, then the presence of other intelligent hominins in our past raises an unsettling question. What if we were not the only ones to awaken? History is filled with stories of mysterious, human-like creatures lurking in remote landscapes, seemingly out of place yet deeply embedded in the folklore of countless cultures. If Homo sapiens evolved alongside other hominins, as the fossil record suggests, then is it possible that some of them never truly disappeared? The extinction of early human relatives like Neanderthals and Denisovans is well documented, yet their disappearance does not necessarily mean total eradication. Modern genetics has already confirmed that fragments of their DNA remain within us, proving that our ancestors interbred with these species. But what if remnants of those populations, or others yet undiscovered, persisted in isolated corners of the world? The idea may sound far-fetched, yet reports of large bipedal, human-like creatures span every continent and every civilization, from the Himalayan Yeti to North America's Bigfoot to the Almas of Central Asia. While cryptids are often dismissed as folklore, certain aspects of these stories align eerily well with known hominin species. The descriptions of these creatures often match features found in extinct members of the human lineage. Large brow ridges, heavy-set frames, a thick covering of hair, and a way of walking that is neither fully human nor fully animal. If similar accounts existed in only one culture, they might be ignored, but their near-universal presence suggests something more than myth. Many indigenous tribes and remote communities do not regard these beings as fictional, but as rare, elusive members of the natural world. The Sherpa people of Nepal and Tibet speak of the Yeti not as a legend, but as a real creature, one that they believe exists in the high-altitude forests. Likewise, in the Caucasus Mountains, the Almas has been reported for centuries as a primitive, human-like being, known to avoid contact with modern civilization. Native American cultures have long spoken of Sasquatch as an intelligent forest-dwelling entity capable of evading humans with remarkable skill. If these stories are purely legend, then why do they describe features that match known archaic humans? One of the strongest arguments against the existence of surviving hominins is the lack of physical evidence. Skeptics point out that no modern bones, bodies, or DNA samples have been found that conclusively prove an unknown hominin is still living. But history has repeatedly shown that large species can remain undiscovered for centuries. The mountain gorilla, now well documented, was once dismissed as a mythical creature by Western scientists until its existence was confirmed in 1902. Likewise, the coelacanth, a deep-sea fish believed to have gone extinct 66 million years ago, was found alive in the 20th century. If such creatures evaded discovery for so long, is it so impossible that a reclusive hominin species could do the same? One of the greatest challenges in uncovering proof of an undiscovered hominin species is their assumed intelligence. If such beings exist, they would not merely be animals wandering aimlessly in the wilderness. They would be our closest relatives, capable of hiding, avoiding detection, and perhaps even understanding human threats. Unlike gorillas, which exist in groups and leave obvious traces, a small, scattered population of surviving hominins could theoretically remain undetected in dense forests or remote mountain ranges. The concept of a surviving archaic human species gains further weight when examining the timeline of known extinctions. While Homo neanderthalensis officially disappeared around 40,000 years ago, some evidence suggests that small, isolated groups may have survived much longer. In Siberia, Neanderthal-like DNA has been detected in samples only 20,000 years old, long after they were assumed to be extinct. The Denisovans, even more enigmatic, are known only from a handful of fossils, yet their genetic traces remain in modern populations, particularly among indigenous Australians and some Tibetan groups. If a species could leave behind its genetic imprint, yet leave almost no physical remains, then how many other hominins might have done the same? One of the most compelling cases for recent hominin survival comes from Indonesia, where Homo floresiensis, often called the Hobbit, lived until at least 50,000 years ago. This species was small, standing just over 3 feet tall, with a mix of primitive and modern features. But what makes its story truly strange is that local legends from the island of Flores describe creatures remarkably similar to these small hominins, hair-covered, intelligent, and skilled at evading human contact. Some researchers speculate that these beings may have survived into much more recent history, possibly even within the last few centuries. If an ancient human species could persist that long, then why not others? There are also historical records that hint at encounters with unknown hominin species. In 19th century Russia, reports surfaced of a captured female hominin known as Zana, who was described as having ape-like features, immense strength, and a lack of spoken language. She was reportedly held in captivity for years, and some claims suggest that she bore children with local men. While these accounts remain controversial, some researchers believe that DNA evidence from her supposed descendants could reveal whether she was in fact a surviving archaic human. The implications of a surviving hominin species would be profound. It would mean that the human evolutionary story is not yet over, that Homo sapiens may not be the last remaining branch of an ancient, complex lineage. It would also raise ethical questions about how such beings should be regarded. If they exist, are they animals, or are they closer to us, intelligent beings deserving of protection, rights, and recognition? There is also the unsettling possibility that if a surviving hominin species exists, it has already been encountered but has been actively hidden from public knowledge. Governments and scientific institutions have long been accused of dismissing or suppressing evidence that contradicts mainstream narratives. Could it be that evidence of archaic human survival has been ignored, dismissed, or even covered up to prevent disruption of the established timeline of human evolution? Some researchers believe that the reluctance to acknowledge the possibility of surviving hominins stems from the challenge it would pose to existing evolutionary models. If Homo sapiens coexisted with other hominin species far more recently than currently accepted, then our understanding of human history would need to be rewritten. It would mean that modern humans were not always the dominant species, that for much of history, we may have shared the world with others who were like us, yet different. The search for these elusive beings continues, but the evidence remains frustratingly inconclusive. Footprints, hair samples, and eyewitness reports emerge regularly, yet no definitive proof has been obtained. Some believe that new advancements in genetic technology may one day provide an answer, allowing us to test unexplained DNA found in remote regions. Others argue that, if these beings exist, they may be intentionally avoiding human contact, recognizing us as a threat rather than a curiosity. Regardless of whether any surviving hominin species is ever discovered, The very persistence of these stories across cultures and generations suggests that something has long haunted the edges of human perception. Whether these beings are remnants of a lost lineage, misidentified animals, or something even stranger, they remain one of the most enduring mysteries of human evolution. If consciousness set humans apart from the animal world, then the possibility of another hominin species still walking among us raises a profound question. Are we truly alone in our intelligence, or is there another branch of humanity that, for reasons unknown, has chosen to remain hidden? If even a single one of these ancient species survived, it would mean that our understanding of what it means to be human is far from complete. And if they are out there, watching from the shadows, what might they think of the species that once shared the earth with them? If ancient hominin species still exist in secrecy, it raises an even more unsettling question. What if they were not just remnants of an extinct lineage, but evidence of something even deeper? What if, in the distant past, humans were not the only intelligent species developing tools, culture, and complex societies? The idea that Homo sapiens stood alone as the pinnacle of evolution is a comforting one, but history does not support it. Fossil evidence already confirms that multiple hominin species once coexisted, each possessing unique traits that could have shaped the future of intelligence on Earth. But what if some of them were more advanced than we have been led to believe? Archaeology and genetics have revealed that at least 4 known intelligent hominin species lived alongside early humans: Neanderthals, Denisovans, Homo floresiensis, and the recently discovered Homo luzonensis. Each of these species displayed behaviors that hint at cognitive abilities far beyond those of ordinary animals. Neanderthals crafted tools, created symbolic art, and buried their dead. Denisovans, though still largely a mystery, left genetic traces suggesting that they adapted to extreme altitudes, an ability that modern humans only developed much later. The so-called hobbits of Flores had brains much smaller than modern humans, but still showed signs of problem-solving intelligence. These species were not primitive. They were capable, resourceful, and in some cases, they may have rivaled early Homo sapiens. The unsettling possibility is that some of these lost species may have been on the verge of their own evolutionary breakthroughs before they disappeared. Could they have developed societies, languages, or technologies that were lost to time? And more disturbingly, did our ancestors play a direct role in their destruction? Evidence suggests that Homo sapiens did not simply outcompete other hominins through superior intelligence alone. Some researchers propose that humans actively wiped out rival species, viewing them as threats rather than kin. The traces of interbreeding in our DNA hint at moments of coexistence, but they also suggest a darker truth. When faced with competition, Homo sapiens may not have shared the Earth willingly. The idea of parallel evolution is not limited to known hominin species. Some discoveries point to the possibility that entirely unknown intelligent beings may have walked the Earth alongside our ancestors. Mysterious artifacts, anomalous skulls, and unexplained genetic markers all hint at the presence of lost branches in the human evolutionary tree. Some of these traces are difficult to categorize, with skeletal structures that do not match any known species. These anomalies are often dismissed as misidentified fossils, but their implications are profound. If multiple species capable of advanced thinking once roamed the planet, then what caused them to disappear so completely? One of the most significant pieces of evidence suggesting parallel evolution is the growing number of unexplained tools and structures that predate known human civilizations. Artifacts discovered in regions where Homo sapiens were not believed to have been present suggest that another intelligent species may have developed independently. In South Africa, stone tools have been found dating back hundreds of thousands of years, long before Homo sapiens are thought to have emerged. Some of these tools are too advanced for their supposed time period, raising the possibility that they were created by a different hominin species with an unexpected level of sophistication. Even more puzzling are the cave paintings and petroglyphs that depict figures with elongated heads, strange proportions, or non-human features. While many of these can be explained as artistic interpretations, some researchers argue that they may represent encounters with beings who did not belong to our species. Some of the oldest known artwork in the world, found in Indonesian caves, predates the known migration of Homo sapiens to the region. This suggests that another intelligent species may have been responsible for its creation, but if so, what happened to them? The possibility of parallel intelligent evolution also extends to other regions of the world. In Central Asia, legends speak of a race of beings known as the Almas, described as humanoid but distinct from modern humans. Indigenous Australian traditions tell of a people who lived before the arrival of Homo sapiens, possessing knowledge that has since been lost. In some cases, oral histories describe interactions between humans and these beings, but if such encounters did occur, then their traces have largely vanished. There is also the question of why Homo sapiens ultimately became the dominant species while others faded into extinction. Some researchers argue that the key factor was adaptability. While other hominins may have been intelligent, they may not have possessed the same level of flexibility when faced with environmental changes. Climate shifts, food scarcity, and natural disasters may have wiped out competing species, leaving only the most adaptable to survive. But this explanation does not account for the possibility that some species were actively hunted or driven to extinction by early humans. Another unsettling aspect of this mystery is the potential for lost technology. If another intelligent species evolved alongside Homo sapiens, could they have developed tools, structures, or knowledge that did not survive into the modern age? Some ancient sites contain inexplicable engineering feats that seem beyond the capabilities of early humans. While mainstream archaeology attributes these achievements to human ingenuity, alternative theories suggest that lost hominin species may have contributed to early civilizations in ways that have since been forgotten. Genetic evidence also raises questions about parallel evolution. Some human populations possess DNA markers that do not match any known hominin species. These genetic fragments suggest that interbreeding may have occurred with an unknown group, one that does not fit neatly into the current evolutionary framework. While some scientists argue that these anomalies could be due to gaps in the fossil record, others propose that they hint at interactions with an unidentified species. If true, this would mean that Homo sapiens were not the sole inheritors of intelligence on Earth, but rather one branch of a larger, more complex evolutionary experiment. One of the most controversial theories regarding parallel evolution is the idea that some of these beings may not have vanished at all. Instead of being entirely wiped out, could they have retreated into hidden regions, avoiding contact with the dominant Homo sapiens? This would align with persistent reports of encounters with unknown humanoid creatures in remote areas. While such claims are often dismissed, they echo the idea that intelligence may not have been a singular event in Earth's history, but a phenomenon that occurred more than once. The implications of parallel intelligent evolution stretch beyond history into the realm of philosophy. If multiple intelligent species once walked the Earth, then what does that say about the nature of intelligence itself? Is consciousness an inevitable result of evolution, or was it an anomaly that occurred in multiple species at once? And if intelligence can arise independently, then does that mean it could still be developing elsewhere in the universe? While the idea of parallel intelligent evolution remains speculative, the evidence suggesting that Homo sapiens were not alone in their intellectual development continues to grow. The more we uncover about our past, the more we realize that history is not as straightforward as once believed. If another intelligent species did exist alongside humans, their disappearance remains one of the greatest unresolved mysteries of evolution. The story of humanity is one of survival, but it is also one of competition. If there were others who once shared this world with us, then their absence is a reminder that intelligence alone is not enough to guarantee survival. Something happened to them, something that ensured that only one branch of the human family tree would remain standing. Whether it was natural selection, environmental catastrophe, or something more deliberate, the truth of what happened to these lost species remains buried beneath layers of time. If intelligence once arose more than once on Earth, then how many times has it been erased? And if it happened before, could it happen again? The past is filled with unanswered questions, and the deeper we search, the more we uncover traces of a world that was far stranger and more complex than we ever expected. If intelligence did not evolve in isolation, but instead emerged through parallel developments among different hominin species, then the evolutionary journey of humanity is far more intricate than previously assumed. But the mystery deepens when we turn our attention to those who, against all odds, seem to have resisted the forces of modernity altogether. While civilizations have risen and fallen, while technology has reshaped the landscape of human existence, there are groups who remain untouched, unchanged, and unwavering. These so-called lost tribes present an enigma. Have they simply preserved an ancient way of life, or do they represent an entirely different evolutionary trajectory, one that diverged from the rest of humanity long ago? The Sentinelese, a reclusive people who inhabit North Sentinel Island in the Indian Ocean, are one of the most well-known examples of an isolated tribe that has resisted outside contact for thousands of years. They have no known agriculture, no written language, and no evidence of metallurgy or technological advancement. Yet, they have survived in complete autonomy, while the rest of the world has transformed beyond recognition. Their hostility toward outsiders has prevented anthropologists from studying them in depth, but what little is known about their lifestyle suggests that they have remained biologically and culturally static for an extraordinarily long time. How is it possible that, in a world where civilizations are constantly evolving, groups like the Sentinelese remain seemingly frozen in time? The question becomes even more perplexing when considering other isolated groups, such as the uncontacted tribes of the Amazon rainforest or the indigenous Andamanese people, who exhibit strikingly distinct genetic markers from neighboring populations. While the rest of the human species has undergone significant adaptations due to migration, climate shifts, and cultural evolution, these tribes appear to have been shielded from the same pressures. Could they be living relics of an earlier stage of human development, representing a window into the distant past? Or have they, in some way, taken a different evolutionary path, one that modern science has yet to fully understand? Genetic studies of isolated populations reveal anomalies that raise even more questions. Some of these tribes possess unique immune system adaptations, resistance to certain diseases, and even genetic markers that are not found in other human populations. In some cases, their DNA shows reduced signs of mixing with other human groups, suggesting that their lineage may have been largely unaltered for thousands of years. If Homo sapiens have constantly evolved in response to environmental changes, then why do these groups exhibit a level of genetic consistency that defies conventional evolutionary expectations? One of the most puzzling aspects of these lost tribes is their apparent lack of technological progression. While early humans were constantly innovating, developing tools, harnessing fire, and constructing shelters. Certain isolated populations have retained Stone Age practices long past the point where other human groups transitioned into agriculture and metallurgy. This lack of development is difficult to explain. If survival is the primary driver of evolution, then why have these tribes not sought more efficient ways to gather food, build more durable shelters, or create more advanced tools? Could it be that their environment has remained so stable that adaptation was never necessary? Or is there a deeper, more fundamental reason why they never progressed beyond a certain point? Some researchers propose that cultural isolation may have played a role. In societies that remain small and insular, there is less opportunity for knowledge exchange and innovation. Without external influence, the process of technological advancement may have slowed to a near halt. But this does not explain why certain tribes actively resist modernization, choosing instead to uphold ancient traditions while the world around them changes. If human nature is to explore, adapt, and evolve, then why do these groups remain steadfast in their ways? Another factor that adds to the mystery is the spiritual and mythological beliefs held by these tribes. Many isolated groups have origin stories that depict their people as separate from the rest of humanity, as if they see themselves as belonging to a lineage distinct from other human beings. These myths often describe ancestors who were different from outsiders, sometimes referring to them as divine or even non-human. While these stories are often dismissed as folklore, they hint at a perspective that suggests these tribes may have maintained knowledge about their own origins that has been lost to the outside world. Could it be that they have preserved an awareness of their distinctiveness that modern science has yet to confirm? There is also the question of longevity. Some isolated tribes are believed to have lifespans that exceed those of modern urban populations, despite lacking access to medicine, technology, and globalized food supply chains. While this could be attributed to diet, lifestyle, or genetic factors, it raises the possibility that they have retained biological traits that were lost in other human populations through the pressures of modernization. Some of these groups exhibit remarkable resistance to diseases that have devastated more interconnected societies. If evolution is supposed to refine the human species for survival, then why do those who have remained disconnected seem to possess advantages that others have lost? The study of lost tribes also challenges the conventional understanding of human migration patterns. While it is widely accepted that Homo sapiens originated in Africa and spread across the world, the presence of certain genetic lineages in remote areas complicates this narrative. In some cases, DNA analysis has revealed links between isolated populations and ancient human groups that were thought to have vanished entirely. Could it be that some of these tribes are remnants of early branches of humanity that took a different path, one that allowed them to persist in ways modern humans did not? Another unsettling aspect of these tribes is the way they react to outsiders. Unlike civilizations that seek expansion, trade, and interaction, many of these groups display immediate aggression or withdrawal at the mere sight of an outsider. The Sentinelese, for instance, respond with violence to anyone who approaches their island, even when there is no clear threat. This suggests a deep-seated instinct to remain hidden, an instinct that may have developed over centuries of avoiding extermination, enslavement, or assimilation. If they have managed to survive by deliberately remaining unseen, what does that say about their history? Could they be the last survivors of a once larger population that was nearly wiped out by early Homo sapiens? There are also reports, though largely anecdotal, of tribes that have vanished without explanation. Some explorers and anthropologists have documented encounters with groups that seem to have existed in total isolation, only for later attempts to locate them to end in failure. This has led to speculation that there may be even more undiscovered human populations living in the deepest jungles, the most remote mountains, or even hidden underground. If such groups exist, how have they managed to evade detection for so long? And what would their existence mean for our understanding of human history? For centuries, humanity has searched for answers about its origins, but the deeper we dig, the more unsettling the questions become. There are gaps in our history that defy explanation, fossil records that don't add up, and genetic anomalies that suggest someone may be missing from our evolutionary puzzle. We are not just the product of a linear path of progress. We are the last survivors of an ancient, complex lineage filled with forgotten civilizations, lost hominin species, and evolutionary leaps that science still struggles to comprehend. Somewhere in our DNA, there are echoes of beings we never met, species that vanished without a trace, and perhaps mysteries that were never meant to be uncovered. If intelligence was not unique to Homo sapiens, then what happened to those who came before us? Were they wiped out by natural selection, destroyed by our own ancestors? Or, most disturbingly, are some of them still here, hiding in the shadows of history, waiting to be found? These mysteries do not just reshape our understanding of the past, they challenge everything we think we know about what it means to be human. Because if there were others like us, if there were beings who built, created, thought, and thrived only to disappear, then the question is no longer just about where we came from. It's about whether we, too, are just another chapter waiting to be erased. But what do you think? Could history be hiding something far more extraordinary than we ever imagined? Leave a comment below with your thoughts. What mystery haunts you the most? What theory do you believe could change everything? And if you want more deep dives into the unknown, subscribe to the channel and turn on notifications. Because trust me, this is just the beginning.